What if one AI tool could help you create content, analyze the data, create images, summarize research, build workflows, design apps, and even prepare you for real-world AI projects? That is exactly what today's session is about. Hello everyone and welcome back to Simplilearn. In this video, we will explore how generative AI is changing the way we work, learn, create, and solve the problems. Today, AI is no longer just a tool for answering questions. It can help professionals translate content, analyze customer feedback, generate marketing, copy, create, design, automate workflows, build product roadmaps, and even support data science and machine learning tasks. And this topic is important because the future belongs to the people who know how to use AI smartly. It is not just about typing a prompt, it is about giving the right context, asking better questions, checking the output, and combining AI tools with strong technical knowledge. In this session, we will cover practical use cases of ChatGPT, image generation, multimodal AI, custom GPTs, automation tools like Zapier, design tools like Canva, and Miro AI, and also AI-powered tools for research, video creation, transcription, and data exploration. We will also look at important data science and machine learning concepts such as pandas, data cleaning, regression, classification, confusion matrix, precision, recall, and assemble models, and also imbalanced datasets. By the end of this video, you'll have an understanding of how generative AI can speed up creativity, business, analytics, and technical workflows, and why human judgment is still very important. Before we move ahead, let me quickly share something exciting for business leaders and professionals who want to understand how generative AI can actually transform work. The Michigan Engineering Professional Engineering Generative AI Applications for Leaders is designed to help leaders go beyond basic AI tools and learn how to apply generative AI across real business functions like sales, marketing, customer services, analytics, product research, software engineering, and workflow automation. The program includes live online interactive classes, real-world case studies, peer discussions, and hands-on exposure to tools like ChatGPT, Microsoft Copilot, Hugging Face, OpenAI, Zapier, Make, Figma, Power Apps, and more. You'll be also working on 12 industry-focused projects, including automation content workflows, building generative AI-powered support agents, designing AI-driven campaigns using generative AI data analytics, and planning product launches with Copilot. On completing the program, you'll also earn a program completion certificate from Michigan Engineering Professional Education, along with the Microsoft Course Completion Certificate hosted on the Microsoft Learn portal. So if you're a leader, manager, entrepreneur, or even a professionals who want to use generative AI strategically to improve productivity, innovation, and business impact, this program is worth checking out. The link is given in the description box below and in the pinned comments. Go check it out. Before we move ahead, here's a quick question for you. Which of the following is most important for getting better results from generative AI? Is it using very short prompts, giving clear context and instructions, asking only one question, trusting the output without checking? Let me know your answers in the comment section below.
So we're going to start today by doing this one, and then as I said, we'll move to lesson two. So this practice is to leverage ChatGPT and a little bit of prompt engineering potentially to create a 2x2 kind of prioritization grid. And the background to this is to kind of analyze potential product features based on two criteria. So, namely, their business impact as well as their feasibility, like how possible is it to actually build those features. And we'll organize those into kind of this 2x2 grid to determine which ones we should prioritize, which ones we should deprioritize based on this grid. So it's an interesting kind of way to organize your thoughts maybe around different features, different ideas. Um, and we'll use ChatGPT to help us do that. Um, so again, this kind of scenario is we are imagining we are working as the CEO of BillSmart, a SaaS software as a service company offering billing solutions for retail businesses. We want to add uh, AI powered flyer generator to make your product stand out. And it will dynamically create visually appealing flyers, et cetera, et cetera, et cetera. So our goal is to, again, kind of assess the priority and feasibility of potential features we could add to this flyer generator product. And we will organize those into this grid and see kind of how they get prioritized according to their impact and feasibility. So here's the potential features that we're going to rank. And they're not really in any particular order necessarily, right? But they're going to be placed into this grid. So these are potential features. And of course, we could have a larger list than this. We just have several of them here, which is basic flyer generation. So generate flyers with product images, prices, promotional details. So just the basics. That's probably a standard feature that we should do, obviously. And then personalized flyers. So tailor flyers to specific customer preferences or purchase history. So that one may require using more data, more purchase history from users, um, and then we can try to build out custom flyers that way. Seasonal themes, so automatically adjust flyer designs based on holidays or seasons, and then analytics integration provide insights into which flyer designs drive higher sales. So integrating analytics there um, to see which flyers are the best. So those are some of the features. Now, of course, you might have some others you want to add to this list as we're going through this. That's totally fine. Whatever ideas you have, you can definitely add them in there. Just starting out with these four. And what we're going to do is we're going to ask ChatGPT to help us generate this grid to assess these features and basically assign it to the appropriate quadrant of the grid. Um, So, and then at the end, we can come back and answer some of these questions once we've created that grid and see, uh, see what it's produced for us. So maybe we'll come back to these questions. But let's take a look at, I wanted to go through and take a look at some of basically the requirements of the grid, which are that we want to basically have four different quadrants of the grid. So in the top right of the grid is going to be um, this section that includes features that have high impact and high feasibility, meaning, they're really doable, but they drive a lot of impact. So these would be um, up in the top right, and we could think of those as kind of like our quick wins category of features. Then there's ones that are less doable, maybe take longer time, and but they still have a pretty high impact, and those would be in our top left category. Those we could think of as kind of strategic investments. Like we should be working on those. Those are features that are important. They do have a lot of impact. They just take longer to do. Um, they have lower feasibility. Then we have low impact but high feasibility. These would be the bottom right, and this would be kind of incremental improvements. These are ones that are really, really doable. They just don't have as much impact. So they're kind of incremental, smaller wins. Um, right? They're doable. They just don't have as high of impact as a feature. Then we have kind of the last category is the bottom left, which is low impact and low feasibility. So uh, this is not having a lot of impact, also not being very doable. So we should probably just deprioritize those. So this would be kind of a bucket of features we should probably just deprioritize. And then, of course, here's the features we want to evaluate. And we're doing them on those two criteria, impact and feasibility. So it's really, if I were to draw it out, it's really kind of a grid where we're measuring impact this way, and then feasibility kind of this way, right? Feasibility. So, so exactly what this kind of describes, the quick wins would be in this corner, high impact, feasibility would be up here, and then the high impact, low feasibility would be high impact, low feasibility would be down here in this picture. I know it says top left, but in this picture, um, and on and on and on, right? Okay, so this would be kind of the prompt we want to use as an example. So just to organize this, our thoughts around this, right? If we were doing this, this is something we would definitely want to do, which is provide a bunch of context. So we wouldn't just jump in and say, okay, here's my features and I want you to put in a 2 by 2 grid. You never know where that's going to take you. But this is providing a lot of detail. That's why it looks like a really big prompt. And it's because we have, a lot of information that's good as background. So for instance, we're talking about the kind of product we have, which is product flyers for retail customers. Just to describe a little bit about what that product is. And then we're talking about an example. It's almost like a one-shot example prompt, right? So we're saying, here's a bunch of detail about this grid as an example grid. So don't just build out any grid with any kind of criteria. It's actually driven based on these two things I really care about, which are impact and feasibility. And so we have a bunch of details about that. And then we have our features that we want to prioritize. So it's quite a lengthy prompt. And in reality, what might happen is it might take us a few iterations to land on this step. Like, we might have to follow up. If we didn't include all of this right away, we might have to follow up and say, oh, I really wanted to prioritize based on feasibility and impact, or I really wanted to prioritize based on these other factors, and that would build a completely different grid, right? So what we can do is paste this in. So this is all of the prompt, but just realizing that, we may not get this prompt right away. There may have taken iteration, may have taken quite a bit of back and forth to land on this, but this is a good example of including a lot of details up front so that we, maybe don't have to spend a lot of time iterating. Not that that's a bad thing, but it does save us some time, right? If we can kind of put that all up front in the prompt. So we'll copy that. And then I'm coming over to ChatGPT and just entering that in here. So we have a bunch of details. Here's all of our background. Here are the criteria for the grid. We have all that detail in there. If you want to try this yourself, by the way, you can use this text as well. Okay, so it says here's a grounded way to map these features. By the way, that was a pretty fast generation, right? Didn't take too long at all. Here's a grounded way to map these features in a practical SaaS lens. I'll place them each in a 2 by 2. So our quick wins are basic flyer generation. So it says this is our foundation. And if it isn't strong, nothing else matters. So this is high impact, high feasibility, even gives you some examples of what we can do to accomplish this. So this first basic flyer generation gets put in the quick wins category. Then we have our strategic investments category, which is high impact, low feasibility. The personalized flyers go there. That can have a really high impact. That makes sense that it categorizes that in that category, but it takes longer to build that out. Namely because you need data collection and to maybe do some type of modeling there. This is where we can use some of the things we've learned in the past, right? We can do things like clustering to segment the customers into different groups in order to maybe have like 5 different kinds of flyers for 5 different kind of groups of customers. We can do that, and we have we've done that in terms of building those kind of models, but we need data to do that, right? So that would be that's why this isn't a low feasibility category, because it just takes longer to build that up, to get that data set going. In another example, we could build out recommendation systems. We've talked about how to do that using, collaborative filtering or even more advanced methodologies. So that's possible. So different ways to come up with what types of personalized flyers we could generate, but that just is a lot more effort than just a basic flyer. So that's why it's in this category. But it could drive a lot of impact. It could be really, really impactful. Um, just obviously takes more effort and longer, more data collection. As I said, it's not trivial. Then in the low impact but very doable is seasonal. So that's very doable. It's just driven based on the time of the year, but may not have as much impact as being highly personalized year round. So it gets put into this category. And then the low impact, low feasibility is analytics integration. So it says that, and the reason, so what's nice is it gives you a reason for this, putting it in that category. So it says insights are valuable only after customers are actively using flyers. So low feasibility because it requires a lot of tracking and data gathering and pipelines. So in general, like spinning up analytics is a huge effort. So it takes a lot of time. Um, but don't really need to do that right now. It's kind of low impact initially, and doesn't mean like in the very, very long run might, could definitely have impact, but it's deprioritized amongst these other things. So that's and so it gives you this final grid right here, basic flyer generation, personalized flyers, seasonal themes here in this bottom corner, analytics integration, bottom right corner, deprioritized. Okay. So hopefully that makes sense. I mean, that's a pretty easy example with GPT. But one of the reasons to go through this practice is to see how the example and details in the prompt really, really help you. And I think that's something we have a good feel for, especially based on when I asked you guys about your own use cases last time. Um, I was really glad to hear that a lot of you are already using generative AI, so that's pretty cool. Um, so you probably have a good feel for this. But just seeing it kind of again here, a lot of these details, if we were to take them away, um, it can go in any direction. And so if we wanted to go in a specific direction, we got to provide those context deals in the prompt as much as we can, right? And realistically, it might take several back and forths to get to that point. So that could be something else different than this, is maybe we start out with just a generic grid and then we kind of have to add to that. No, I really want to use, impact and feasibility. Um, that could be a possibility, but you don't have to do as much of that iteration if you kind of include more of that up front. Not that, again, not that iteration is a bad thing. You may have to iterate, and there's nothing inherently wrong with that. It just takes more time. Okay. Any questions um, based on this demo? Were you guys able to try? Did you have access to this prompt? Were you able to run it through? And there's not, by the way, there's also nothing special about GPT. You could run this through any one of the language models that are out there and kind of compare and contrast what it comes up with. Um, but pretty simple example, just running through this prompt. And again, it's sort of close to a one-shot example because we are providing details about the kind of grid that we want, almost like an example. Um, and maybe to take it one step further, we could have provided a previous example of like some other two by two grid we made for another project or another product. That might be pretty valuable as well as like another example. That could be something we add in here, but we're providing a bunch of context really about that. So it's not quite a polished example that we're providing, but it's a lot of really good context about the grid rather than just saying, oh, just put it in a two by two grid, right? Okay. Very good. So let me, there's no other questions about that one. We can stop that practice and go on to lesson two. Pretty straightforward, just working with ChatGPT. Again, there's times where that may have required a bunch of iteration to land on the proper output that you want. And there's really nothing wrong with that. But it's something you probably have a good feel for is like the better you get at including the details up front, the less time you have to spend iterating, which can just save you time generally. Okay, so now we're going to move to lesson two. So if you have these notes and you want to pull those up, we're going to move over to lesson two, which is going to be a lesson just full of demos, full of lots and lots and lots of demos, more demos than we've probably ever done in one lesson. It's going to have a lot of them. Mainly because this lesson's all about showing off various capabilities of generative AI. Again, a lot of them you're probably aware of, but if you're not and you haven't worked with it that much, I think it'll be a really interesting lesson to see some of those capabilities showed off here in our various demos. So we'll work with a bunch of different tools. So throughout the demos, kind of like when we did the Hugging Face spaces, we're gonna just show off a bunch of different really cool Gen AI tools along the way. That's kind of the focus of this lesson. So a lot of demos, a lot of jumping back and forth between the slides and the demos that we'll do here. So, our objectives for this lesson are to really look at how generative AI is applied to a bunch of different real world examples, so a bunch of real world tasks. We'll take a look at some of the multimodal capabilities. So, this is kind of like expanding just having text input, which is usually just a prompt, right, into something like a, a language model. And nowadays, they can actually work with many kinds of data as input. So they can work with various files like CSVs or spreadsheets. They can work with images. They can even work with audio and video. So, we'll explore those capabilities by doing a demo with that. Um, We'll take a look at some demos with some various custom GPTs. So if you've never worked with those before, they're pretty interesting. These are models that have been fine-tuned for specific use cases. So things like creative writing or educational research, or actually doing education tutoring. Um, if you've never worked with those, I think it'll be cool to see some of those capabilities. So we'll do that. And then we'll take a look at some workflow automation tools that leverage Gen AI. So things that you may have heard of, Zapier, Otter, a bunch of different tools that can help us automate workflows. And we'll do some hands-on with those tools, which I think will be interesting if you've, again, never worked with them before, um, or never seen them. I think it'll be interesting to take a look at those. So a lot of demos, a lot of hands-on stuff today, which I think will be great. Okay. So the first place we'll start is expanding our horizons on some of the capabilities of ChatGPT. So I I have heard from you all that you use these kind of models quite a bit. So it's not surprising that they can do these kind of tasks like language translation, social media profile, or post creation, um, even doing customer reviews, sentiment analysis. They're all capable of doing this. And a lot of this stems from um, going all the way back to Transformers, right? They were designed to be able to handle language tasks, NLP tasks, which really fall into these categories, things like translation, sentiment analysis, text generation, and summarization, and on and on and on, a bunch of different language tasks. It's no surprise that these transformer inspired models can handle these kind of things. That's what they were designed to do. And so we will take a look at some demos that can do each of these things just to show them off. Um, and it really will be no surprise that they can handle these pretty easily. Um, so we will do that. The first place we're going to start is uh, first place we're going to start is with doing a language translation. So we will pretend that we are operating an online bookstore, and we want to translate a bunch of our snippets from our books, like our titles or various excerpts from the books, into various languages. And so, if we wanted to do that quickly, we could use AI to do that, right? We don't need to use kind of really old translation technology. Uh, we can use generative AI. It's really capable of doing language translation. So we'll take a look at that. Quick question on a different topic. Sorry. No worries. We haven't discussed the projects for deep learning. No, we didn't I didn't go into details on those projects. No. But yes, there are projects available for that course. And it's the same as usual where you want to do one of them to get the certificate for that course. So yes, I would try one of them, and um if we want, we can talk about them later on. If maybe on Monday, um, we can go back and discuss some of those if we want. Um, but I didn't cover the specifics of those projects, but there are options to multiple project options that revolve around deep learning. So would give those a try. It's the usual. You only have to submit one of them to get the credit. But yes, there are project options. So I would take a look at them, see which one seems doable, and give that a try. Yeah. I think if I remember, there's a few options. One doing computer vision, um, one doing a more traditional modeling, like doing a binary classification. So and then another one doing, I think, another kind of image recognition. So there's a few options that are sort of aligned to projects that or examples that we've done before. Um, so there'll be things close to kind of examples that we've worked on for sure. So inside of lesson two, there's a bunch of demo documents, quite a few of them, and we're going to try our best to work through all of them today. Um, and so this is the book translation example. So what we're going to do is just read through the scenario and then really kind of utilize this prompt utilize this prompt into ChatGPT to kind of show off its language translation capability. So the background scenario is what I had said before. We are an online bookstore that offers a bunch of books in multiple languages to cater to a global audience. To expand our reach and provide readers with books in their preferred language, we're going to use ChatGPT for real-time book translation. So our goal is to take some excerpts from the book, and these excerpts may actually be, advertised on our website, for instance, as, pieces or snippets from the actual text of the book. But when someone logs in from Japan or from India or from Europe somewhere, we want maybe we want this to display in kind of the local language that is in that region whenever someone accesses our website. That could be a use case, right? And so we could use something like generative AI to do that for us, to do that translation. So so our prompt here is to just to show off that capability translate the following book excerpt into multiple languages to make it accessible to a broader audience. So we have this excerpt, which is from this book, Journey Through the Echoes, Captivating Exploration of Ancient Civilization. So this is just describing a little bit about the book, and it's an excerpt from it. And so we'll copy this scenario and our prompt and our excerpt, and we will paste this in. And again, a lot of background information, a lot of context provided, but mainly what we're looking to do is generate this translation of this text here into multiple languages. So let's paste that in. So here's our excerpt from the book, and here it is. So what we're expecting to get are multiple translations. Now, something that you may have noticed is we're not providing specific languages that we're hoping it translates into. If you want to see specific ones, feel free to tweak this and add those in. So where it says multiple languages, you can specify explicitly which ones you're targeting. In a real application, we may grab that from their IP address location or something like that, and then supply that location to kind of infer what language we should be producing, and then use that kind of in real time. That would be a more appropriate way to do that in real time. But we are just seeing an example of how this can do translation pretty effectively. So we'll see which languages it does, but um, if you want to see specific ones, feel free to edit that. Okay, so here are the translations. So it chose to do Spanish, and here's the full Spanish translation of that exact excerpt. So it's just giving us that. It chose to do French, so it has that translation. Chose to do German, so it has that one. Chose to do Chinese, chose to do Arabic, chose to do Hindi. And then it even has a follow-up. It says we can tailor it for specific regions or even like maybe dialects of those or completely new languages if we want. So this is just the sample of the ones that it gave us, but obviously we could tailor this to the use case. But this is just showing off, these language models are highly capable at doing translation. Very, very good at doing translation. And also notice that it's zero shot, right? It doesn't need any examples. It's just using the model capability. It's just using the inherent model capability to do the translation. We don't need to provide any examples at all. It can just do that kind of out of the box because it's been trained to do that. So there is that. Um, all right. So let's see. So we saw a language translation use case. I think we're fairly confident that it can handle that. Let's see a LinkedIn profile creation use case. So now what we're going to do is ask generative AI, namely ChatGPT, but of course, feel free to experiment. Like if you use other language models and you want to try it out in those, there's no requirement to use ChatGPT, so feel free to use those other ones. I think that's totally fine. But what we're going to do in this situation is imagine we're preparing to create our profile. Um, we want to create a personal brand, so we will use generative AI to help us do that. Um, so let's go over to that demo. Let me open that one up, which is this one. So hopefully you guys have this one. As I said, we're going to be doing a lot of them, um, all the ones in lesson two. So this one is to, again, help us see how ChatGPT can help us create a LinkedIn profile. And what we're going to do is take a look at utilizing the information from a sample resume. So this is kind of a fake resume here. But the idea is we can provide that as background data, as context, right? And what the model will do is kind of extract important details from that to help generate our profile. So we're using this resume um, here. So we have all of this resume details with basic information, objective, education, skills. This is all fake, obviously, but um, uh, bunch of certifications, professional affiliations, publications, etc. And then what we're going to do is ask the model to create a LinkedIn headline that showcases experience, qualifications, and passion using industry relevant keywords. Then we want to write a summary of around 150 words that highlights professional journey and unique skills. In the experience section, provide detailed entries that showcase my contributions. Now this is an important one for LinkedIn in particular. And again, this may be something we would follow up with. It's not that we have to provide this in this initial prompt, but it's good in that it produces a lot of content for us to get up and running with LinkedIn. Suggest content for starting conversations with new connections, focusing on recent industry news or their achievements within 100 words. So beyond just filling out the information that would be in our profile, let's have some conversation starters, focusing on news or their achievements. And then help me craft a LinkedIn post. So we actually want to build a relevant post for our profile, sharing insights on a specific topic with relevant SEO hashtags. So that's search engine optimization hashtags. Offer advice on optimizing my profile to attract recruiters and enhance professional connections. So a lot of information in this prompt. And what I would say is there's probably multiple approaches to doing this. As I said, um, this kind of does everything in one shot. Um, of including all this detail within this prompt. Do we have to do it that way? No, we could break this down into multiple prompts that we follow up with, which would probably be more realistic of starting with, writing out most of the details in the profile. Then maybe later down the road, we come back and ask for content to do conversations. Then maybe at some point down the road, we want to generate a post in which we come back and ask to do the post, and we may have some more context around what do we want to do the post about? Because this just says any specific topic, but maybe we have one in mind, at some point in the future. And then maybe, we can ask for advice whenever. It doesn't have to be within this prompt itself. So, but there, it's fine. We can add all this detail in there up front and save ourselves a little bit of time in the future. Um, but in all likelihood, we'd iterate on this probably with multiple prompts would be realistic. Um, but what's important is, especially for this, we need that resume information. Um, yes, exactly right. So exactly what you said. Wouldn't we need to upload our resume? Yes, exactly right. So you read my mind. Is like, yes, if we're going to do this in particular, we need to provide that resume data with that prompt. And that's what we do here. So it's actually, we could upload it as a file. Here it's just, here's the text of this fake resume. Um, so we have it and we would include this text with our prompt. So we're going to include all of that with this prompt. But you're exactly right. We would definitely want to include that. Okay. So here is our resume details. It's all up front. And then we have our prompt. So create a LinkedIn headline that showcases my experience, blah, 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 blah. Everything we just talked about. And so there it is. So we could um, upload it as a file. That's fine too. But as I said, it's kind of just here in the text format, and we're just pasting that in first. Either way is okay. Um, it would just extract that from the file anyways. So either way works. So let's send that along. So when we do that, it uh, generates a bunch of stuff for us. So we have all those elements that we asked for in the original prompt are broken down into this response. So we have our LinkedIn headline. So we have an AI research scientist, generative AI LLM. So this is just a bunch of different headlines that we could put at the top of our profile or kind of in the headliner of our profile, which are mainly kind of keywords like industry keywords and skills in some way, PyTorch, TensorFlow, etc. So we have that. Then we have the summary. So about 150 words, which is what we asked for. So we have about me, you know, AI ML specialist, strong focus on generative models, large language models, multimodal, etc. And then it has some details about what we're passionate about, etc. So all the details we include in our prompt show up here as they should, right? So that's good. And it even used information from that resume, like currently working as an AI research scientist, specializing in stable diffusion, blah, 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 blah. Cross-modal embeddings, these kind of things. Uh, so um, there we go with the summary experience. So if we were filling out our profile, I wanted to extract a lot of the same information from our um, that would be in our resume, basically expanding on that a little bit here in the experience. So this maybe builds out those bullet points a little bit more detailed than what they were in the original resume, but here they are. So you see the different positions. So this person worked at DeepMind and OpenAI. Pretty impressive. Pretty impressive, John Doe. And then we have our conversation starters. So here's kind of a template. So what it does is it builds out a template for us that we can use to start conversation. So, it says, hi, blank name. I saw your recent work on blank, really impressive, especially your approach to blank. So it gives us a nice little template we can use to, start a new conversation with a potential new connection. So that's pretty interesting. Then we have our first post, right? So again, this is something the post I would say this starter like this and the post um are this and the post are likely things we could have followed up with. We don't really need the resume to do that. And uh um we don't really need the starters as part of our profile creation. They're just additional helpful things if we're trying to build up our LinkedIn, brand, so to speak. They're just helpful things that we might need. So here's a first post, and we have kind of a title of it, and then some details that are right around 200 words. And then importantly, it provides a bunch of hashtags. Now, these are ones that can help it get discovered, right? So they're search engine optimized, um, search engine optimized to, um, you know, uh, be able to make it discoverable by the everyone else's feed who's interested in these various hashtags. Then it has some profile optimization tips. So use a banner image, use the skills section, recommendations, activity, SEO tip, repeat key terms across sections, etc. So um, just some extra tips. Again, one of those things that we don't necessarily need if we're just trying to build out our profile using the resume. That would have been kind of these first three items. The rest of them are just kind of interesting additions to help us get up and running on LinkedIn potentially. But really cool, right? So really cool usage of generative AI. If you haven't ever used generative AI to help you with these kind of things, maybe this gives you some inspiration to try that. So maybe give that a try for helping you craft some posts or conversation starters, or enhancing your profile, about me or summary, those kind of things. You can provide your own resume, try to get that synthesized into this nice about me summary. It's an interesting use case. Can we send the link to extract? I think you can as long as it is public, like you don't have it private. I think that probably will work, although I've never tried that. Maybe give that a try. Maybe sending along your own profile link to see if it'll extract. That's a good question. I think it should work as long as it is uh, not private. Like it's, you can click on it and as from a public view and you can view it. But I've never tried that personally, so I can't say if it does work or not. Software generates spells in strange languages. Yeah, that's a good headliner or about me. Yeah. Okay. Any questions on this one? I think the link is an interesting one. I haven't tried it, but um, would be interesting to try that out. Okay, so we have one more for you here of just basic ChatGPT ones. Um, I want to do sentiment analysis. So this is one that we've looked at before, I think, in terms of language models are generally good at this task as an NLP task, right? Sentiment analysis. So in this one, we're going to take a look at customer feedback and see how that can kind of be obviously automated by a language model that can extract, based on reading that text, extract the sentiment of the feedback and if it's positive, negative, which is a very useful thing for analyzing what kind of feedback you're getting if you're like an online store, online brand, kind of they do this. They do this all the time where they read like social media posts or reviews like Google reviews or Yelp reviews, and they um, will basically summarize it or provide some sort of sentiment analysis of it, like how much of it is positive, how much of it is negative, and you can easily do that through generative AI. You don't actually have to read through every single one and apply a label manually, kind of manually calculate that. You wouldn't want to do that; it'd take too long, especially with lots of posts, lots of feedback. Um, so we can do sentiment analysis with a language model like ChatGPT. So let's practice that one. So let me go to demo 3. And I will open that one. Okay, so hopefully you have this one, demo 3. This is sentiment analysis of user reviews. So what we're going to do is take a look at some various uh, um, reviews from customers that are kind of fake. I mean, these are just fake reviews, but we're going to take a look at categorizing them into these various sentiments, right? So like a positive, neutral, negative sentiment. Um, and that can give us an analysis of, uh, what the review is kind of expressing, almost like a summary of it. We also have a mixed sentiment, contains elements of both positive and negative. Questioning sentiment expresses curiosity. Appreciative sentiment shows gratitude, appreciation, or thankfulness towards the subject. So this is a great example, by the way, of few shot prompting, essentially, because rather than just relying on the model itself to do the sentiment analysis, which it certainly can do, but when you rely on just the model, it's generally just going to categorize things into positive, negative, neutral, right? It's going to be into what the model has been trained on, and most of the time, it's been trained against those three because that's the most basic type of sentiment analysis we can do. This actually has examples of what we're looking for across several different sentiments. So positive, negative, neutral, we have a description of what we're looking for to label something positive. right? A description of what we're looking for to label something negative, and on and on and on. We even have mixed, questioning, and appreciative. And mixed is a little different than neutral. Neutral just means kind of lack of any strong emotion one way or the other. But mixed means you do have elements of both, positive and negative. So, it's mixed in that sense. Um, so these are kind of additional sentiments that we're providing examples for of, this is what we're looking for these sentiments. So we have that. If we didn't provide that, and I encourage you to try this, like if we didn't provide that and we just asked to do sentiment analysis of these reviews, it would likely just do positive, negative, neutral. It would stick with those basics. But here we have some additional sentiments that we are describing um, here. So let's do these sentiments. And then let's do these reviews. So we have one review, two reviews, three, four reviews. So we're going to categorize four reviews into those various sentiments. So categorize the provided review based on the following inputs. So we have positive, negative, neutral, mixed, questioning, uh, and appreciative. And then here's our review. So we should end up with four different sentiments, one for each one of these reviews. Um, let's see what it comes up with. Okay. So number one, it has, it thinks should be mixed sentiment. So number one was a mixed sentiment. If we read number one, let's see if that makes sense. So the number one was, I recently watched Eternal Visions and it was decent overall. The storyline had an interesting mix of mystery and romance, but it left somewhat, but it felt somewhat predictable at times. The acting was good and the cast delivering solid performances, though nothing particularly stood out. The visuals are nice with some beautiful scenes, but they weren't as captivating as I had hoped. The score was fine, fitting the film's atmosphere, but it didn't leave a lasting impression. In summary, it was an okay, it might be worth a watch, but it didn't quite live up to my expectations. So I think that's a fair sentiment, right? It said it was mixed, and it even explains why. It contains some positive things, but also some negative things there too. Um, I think that makes sense. So this gets categorized as a mixed sentiment. Number one, I think that's a pretty good categorization. Number two gets categorized as positive. So if we take a look at that one, it says, I just finished reading The Nightingale by Kristen Hanna, and I was blown away. Storytelling was captivating, weaving together historical events, deeply relatable characters. Found myself completely immersed in the lives of Vianne and Isabel, unable to put the book down. Emotional depth and raw honesty left a lasting impact on me. Highly recommend. So very, very positive. I think that's fair. That seems like a fair. And again, it shows strongly favorable languages with no notable negatives. So it's a positive sentiment for that review. Now, number three gets a negative. Let's see why. So I said I had high hopes for the new restaurant, but unfortunately my experience was disappointing. Ambiance was nice, but the service was incredibly slow. Staff seemed indifferent. Food was mediocre at best, lacking flavor and creativity. Additionally, prices were exorbitant for what we received. Overall, I wouldn't recommend dining. So yeah, that seems pretty negative to me. Pretty unfavorable experience. So yes, this seems like a negative sentiment. Seems reasonable. And then lastly, number four is a mixed. The latest updated app left me with mixed feelings. I mean, we literally use the word mixed feelings in there. That's not a shock that we end up with mixed sentiment, right? While I appreciate the new features and smoother interface, I'm frustrated with the increased battery consumption and the occasional bugs that disrupt my experience. So it is a mixed sentiment there. I think that makes sense. Appreciation for improvements, but also frustrations. So that leads to a mixed sentiment. So again, the example I would give to you guys is in reality, a lot of people are using generative AI nowadays to do this automated sentiment analysis. So they typically have applications set up to route the social media posts that are about them. You can kind of scrape that in real time, and then feed them through the generative AI to kind of generate a sentiment, and you can quickly tell how many posts you have in the last 10 minutes, last hour, last day are positive, negative, neutral, whatever sentiment, and you can gather up those statistics relatively easily, which is useful data, right? Useful data about your posts, about your brand. Um, it's relatively easy to gather from the reviews that people are leaving or from social media posts, whatever kind of text is being generated about your brand or product. um, it's pretty easy to pass through generative AI and get those sentiments. In the past, it was a much harder problem. Usually, you'd have to have someone in the loop actually tallying that up, or you'd have to have a very basic NLP model that would try to do this, that'd be more statistically based, maybe looking like a rules model that's looking for particular keywords um, to label it as positive, negative, neutral. But now we have these really powerful language models that can do that pretty effectively. Okay. Let me pause there. Any questions about this? Uh, any questions about this demo? So as I said, we wanted to take a look at some of the multimodal capabilities of ChatGPT, but it's really true to any of these language models that are out there today. Really has these capabilities that go beyond just working with text, right? Working with prompts that are primarily text-based. Um, so these days they can work with many different kinds of data, especially as inputs or even creating outputs that are images. So we've seen there's various different image models that are out there, mainly diffusion based, that can generate an image, but they can also utilize imagery in the input. So there's a lot of really cool technology involved there. Probably some of the most interesting is the ability to analyze an image in particular and kind of map it into the same context space as text, which is known as kind of like a cross-modal or multimodal embedding. So it's a very interesting idea is to take multiple types of data as the input, but understand the context across all of it in order to generate some type of text output, let's say. Um, and so that's a really strong, amazing capability of these models is that ability to work with multiple kinds of data as input. And oftentimes, like that may be uh, a use case, right? You may have an image that you want to do something with or use as context. You may also have some type of document, like we just talked about the resume that could have been in a PDF or a Word doc or something like that, right? Didn't have to be just the text. And so, what we should realize with this too is these systems, and they really are, I would characterize them really as systems like a ChatGPT are the model and what you see is really just the tip of the iceberg. There's a whole system below the surface. So we just interact with this tip of the iceberg, but really underneath there's this massive um, system there to extract text from documents. So to extract text from documents, to do thinking algorithms, to do image generation. There's all kinds of, it's almost like its own software application. It really is. At the heart of it, though, is of course the LLM. So the LLM plays a really critical role in generating the content, but there's a lot of machinery there that helps process this multimodal data or um, you know, basically do prompt engineering almost automatically with thinking strategies. to help generate the best output possible. Um, but of course, we don't really see all of that under the hood. We just enter our prompts here, and then everything else happens, right? And just works. But there's a lot going on under the surface there. Okay. So, that being said, we're going to do some demos, of course. Um, we'll do those, but the interesting thing is the additional data just helps us provide context, right? At the end of the day, that extra data can provide a lot of context, but there's also a lot of interesting things we can do to that data. We can use it to build like hashtags or SEO tags or captioning for imagery. We can ask questions about the imagery specifically. We can we can extract information from video or audio content, which is interesting. We can also ask for image responses, like build an image that matches this prompt. So these models have a lot of capability of working with multiple types of data, and this is a relatively new advancement. So it hasn't always been that way, but it's a really big capability that's been unlocked really in the past couple of years, I would say. It's pretty strong within the last couple of years. Okay, so we're gonna do a couple demos that will explore these capabilities. So we want to dive into how ChatGPT can work with image data in particular, and analyze an image. So just see an example of that. So let's go over to our demos. Back to those. This is going to be demo 4, exploring multimodal capabilities. Okay. So hopefully you can see that. So exploring multimodal capabilities of ChatGPT. So what we're going to do is we're going to look at two different use cases. We're going to look at analyzing a map. So we're going to have a picture of the United States and ask different questions about it. And then we're also going to see how it can help generate an image. So generate a visualization of a futuristic park. So following a prompt. So we're going to have a prompt to help us generate an image. So just show off some of those capabilities to work with image data, whether that's in the input or generating it as part of the output. Um, so we will take a look at this first prompt. So what we want to do is analyze the image provided, which is a map featuring various geographical locations, including cities, states, and natural landmarks. Identify the country and suggest notable tourist attractions visible on the map. Describe these places briefly and explain their significance or appeal to visitors, focusing on areas that are typically of interest, etc. Right? So when we look at this image, of course, we know what this is. It's obvious. But the computer, what's fascinating is like a machine wouldn't necessarily know what that is. So the ability to kind of analyze this um, image and determine it's the United States, and here's a bunch of interesting things about it that you should visit or be interested in, is really fascinating. So just the ability to work with that image, and we can include that in our prompt. Now, we could also download that image and upload it as a file into the prompt. That's also, possible. But we're just going to include it um, as part of the prompt here, which it should, let me double check. So it should, if I copy that. But yeah, in the maybe because it's in the Word doc, it's not in the PDF, but this works. Just creating a screenshot and pasting that. Okay. So we say analyze the image provided. So it gets it right. It says this image shows a map of the United States, including its states, major cities, surrounding geographic features like oceans and neighboring countries. Here are some notable tourist attractions and regions visible on the map, along with why they draw visitors. So you have New York City, Los Angeles, Chicago, Washington, D.C., natural parks and landscapes. Coastal and regional highlights. And then why this map matters for travelers. So really interesting. It was able to take, even though so this is my screenshot, which was basically the original image. It's able to analyze this, understand it's, the United States there. Um, and then take a look at the analyzing what about this map is interesting. So based on that, we have these various cities, landmarks, and then a little bit of description about what's there. And it even follows up and says, we can suggest a travel itinerary if we want, based on this map. So pretty interesting use case. Let me ask you guys, have you ever been able to work with images in ChatGPT or any language model? Has that ever worked for you guys? Any use cases for that you have that you've been able to work with imagery? Yeah, like I said, it's a relatively new feature of these language models is to be able to process imagery. That is, a recent advancement in language modeling is, as I said, the challenge with this is often, uh, we've talked about attention layers, and what they do is they help us understand the sequence of text all together to understand the context of what words matter to each other. But when you have data that is not text, that becomes a real challenge to understand context. That's really hard. And so, but that's where the advancement has really been is to have these embeddings that can map data like imagery into the same kind of embedding space as text, and then try to also generate kind of context from from that data. Um, and so that way you're able to work with all of this as input to the model. So not only just the text, but the image as well, or audio or video, whatever. So really, really amazing enhancements to, again, all inspired from the Transformer, but especially attention and embeddings, but has been significantly adapted. Back when the Transformer was created, 2017, I don't think they ever envisioned um, working with these different kinds of data like image and audio and video, but we certainly can today, which is fascinating. Okay. So we have that example. Now we're going to ask a slightly different question, which is to create an image. So that example was using an image as input, asking a question about it. Now we're going to prompt to actually create an image. So we are going to utilize this prompt, create an image of a futuristic smart city park at twilight. And we're going to have a bunch of context details about what we are looking for in that image. So this is really a detailed prompt. A lot of details captured here in what we're looking for in the image. So we want an eco-friendly environment where technology and nature are seamlessly integrated, solar panel walkways, bioluminescent plants, interactive digital information boards, really futuristic city, right? Atmosphere should be serene, soft lighting, sky should show transition from sunset to starry night. Background, there should be a skyline of sustainable skyscrapers with green rooftops and vertical gardens. So a lot of detail. And that helps. Like if you want to get a very specific image, all this context detail really helps. And so let's see what we can build if we ask for this. So we can copy that in and we can ask to create this image. And by the way, this is going to do the diffusion kind of process. So the model it's using under the hood to do this is kind of that diffusion process, which is converting our text details that we're talking about here into the right kind of transformations on random noise that can ultimately lead to the final image. So it's kind of like erasing, kind of like backwards erasing noise and wiping that away to reveal what's left behind. Almost like a scratch off ticket. You're scratching off something, leaving something behind, and that is the final image here. So here is what it generates. And this looks pretty good. This follows a lot of the details that we asked for. So we asked for those bioluminescence, the background, sky, scrapers with that are sustainable, walkway, the bioluminescent walkway we talked about. Atmosphere should be screened with soft lighting. So a lot of those details we asked about looks pretty good in this image. But again, there's a very sophisticated model there, that stable diffusion process, which is learning how to generate pixels from text. That's essentially what we're doing, right? Learning how to go from text to pixels. Um, and it's a very sophisticated model that's doing that. Did you guys get something close to this if you tried it out? So this is creating an image. Earlier we were analyzing an image, but this is actually building one using the prompt. And again, this is a very, very new process. Only within the last couple of years has this really been um, available to do, is go from uh, prompt to image. It's a very hard problem in general. Yeah, it's similar, definitely very similar. But slight differences. But yeah, very, very in the same range. And that's not too shocking, mainly because our prompt is so specific. The more vague that we left our prompt, I think that gives more avenues to be creative and be different, and we would end up with likely different images. The more vague our prompt was. But because we have such a specific prompt with very specific details that we're looking for, it kind of narrows down what we're generating, right? Narrows it down a lot. So yeah, we end up with those very similar designs. Very cool. Okay. Any other questions on this one? So yeah, if you've never generated an image before, you can ask it to create images. By the way, all the other providers have image models too. Google Gemini has it. Anthropic has it. They all have these capabilities. Um, so it's not necessarily unique to GPT, but Um, GPT did have the DALL-E model integrated from OpenAI early on, so it was one of the earliest that did provide the text to image capability. And it's gotten better, over time. Okay, so we did that one. Now we're going to take a look at uh, analyze customer feedback once again and take a look at using it for a sales um, e-commerce kind of use case and look at ways to structure um, potential sales strategies and opportunities for improvement. So kind of expanding on the sentiment analysis use case that we looked at before, but categorizing different feedback into the segments and then visualizing the results. So we'll actually do a little bit of visualization, which is where the multimodal capability comes into play. Uh, which is having the best capabilities? Um, I really like OpenAI. I really think the ChatGPT one is really, really good. I think the Google one's really good too. So the latest like banana, um, Yeah, I think the banana model from Gemini is pretty good. The nano banana or whatever it's called is decent. I really think GPT is the best, probably because they've been doing it the longest and have the most practice at it, I think, with starting with the Dolly, which and they've just built off of that for a long time. So yeah, I think GPT is pretty good at it amongst others that I've tried. Okay, let's look at demo 5, customer feedback analysis. Okay, so we are going to take a look at this scenario. So imagine we are a data analyst working for a large e-commerce company. The company has just completed a major sale event and they have collected a large amount of customer feedback through their website and app. The company wants to understand customer feedback, identify areas of success and opportunities for improvement. So it's sort of similar to what we did before. We have a bunch of feedback data. We want to analyze it. And what's interesting is rather than just doing the analysis, which we do ask to do, so given the feedback, categorize it into one of the following categories: positive, negative, neutral, and constructive this time. So slightly different sentiments than we had before. But what's interesting is after we do that, we ask it to do a little bit of analysis. So after categorizing, provide a count in each category and build a graph. So build a pie chart that visualizes this sentiment analysis. So going one step beyond just providing the sentiments, let's actually do a little bit of data visualization of that, which is interesting. Um, So we have to grab the uh, feedback analysis, which there's a lot of comments. I think we have to get that uh, um, from the CSV. Let me see if I have that quickly available. I don't think I do actually. Does anyone have that customer feedback from the data sets? It might be inside of the data sets. I think it's a CSV. Okay, so what we're gonna do is we're gonna upload that into here. So we are gonna paste our prompt. We have our scenario and our prompt we're gonna paste in here, and then we're going to add that file. So customer feedback CSV. We're gonna add that file. So we uploaded that file. So thanks again for providing that. So we uploaded that file and then we have our full prompt and we're going to ask it to analyze this feedback data, um, analyze the data, and categorize each feedback into one of the following categories. So this CSV provide it basically has all that text. It has a lot of them, which is more realistic of a problem. Like I said earlier, if we had product reviews that were coming in rapidly, or we scraped from our app and we dumped into kind of a file or a database, this would be more realistic of a problem. We have a lot of reviews we want to categorize at once and do some type of analysis on. Um, and or maybe it was in more of like a stream from social media. That's another use case. Um, but let's send that along and see what it has to say. So crunching on that. But you want to make sure when you do this, you add the CSV in there as part of the input data, right? So that we can um, analyze the all the reviews that are in that spreadsheet, which is there's a lot of them. Um, So it gives us the count and the visualization. So it looks like it basically produced positive, negative, constructive, or neutral. And we ended up with 136 neutral, 131 positive, 10 negative, and 3 constructive. And here is the graph of that. How many neutrals did you get? 190. Wow, that's a lot more. So it must have took some of those positives and thought they were neutral. That's possible. Yeah, it's possible to get slightly different interpretations of the reviews and have different numbers there. That's totally possible. Wow, completely different results. What models are you guys using? Same ones, GPT? Gemini, okay. So it had a lot of uh Gemini seemed to lean heavily on the positive. Any more in the free model? Oh, I gotcha. Overused it. Yeah, no, that's a great question. So could we add anything to the prompt so the data should be stable in any model? That's a great question. And yes, we could. So I think what we could do is provide examples. So if we provided explicit examples on these reviews are positive, these reviews are neutral, these reviews are negative, that could give some guidance into what an example looks like. Um, remember that, um, remember that, these are probabilistic. So that's why we're seeing some instability and we get slightly different answers even across the same model. We get slightly different numbers and we may get that even on different runs. Like if I refresh this and reran it, I might get different numbers. um so what could really help is providing explicit examples on what we think is neutral, what we deem to be positive, what we deem to be neutral, what we deem to be negative. And those examples can guide the basis for predicting all the others and give us a little bit more stability. So that's where like the few shot prompting really comes into handy there. So I think that would be something to do. But yeah, same data giving you many different ones. I'd be interested to try. I might actually try Gemini as well. Let's see. So let's try it. Let me see if I get a different answer as well. If we were doing anything new, we won't have the example. Um, that's where we have to come up with our examples. Yeah, like you're right. Like if we're doing anything new, we likely won't have an example, but that's where we could spend some time creating our own labels, and that might be helpful. So, um, but yes, we would have to come up with those. We'd have to do some extra work to come up with the labels for anything new. I agree with that. Other than examples, I'm not sure. I don't think there is really because these models are inherently probabilistic. So there's no guarantee you get a stable answer every single time, and certainly across models, there's no guarantee. So unfortunately, I don't think so. I mean, the other aspect of this is if we had data that was way more decisive one way or the other, it could be that there's some data that's kind of on the fence where it has some mixed. So the other thing we could do is change our labels to maybe there'd be something more appropriate like mixed rather than neutral that has some combination of positive negative. So if we just change up our labels a little bit, maybe that could help categorize things more clearly and distinctly into those labels. So using the right labels um, for the problem, like based on maybe some preliminary analysis that we do of just a sample of the reviews, that might be helpful to do as well. Get a little bit more stability. Yeah, I think the examples will definitely be the best. Now, by the way, another step to this is if we were always doing, like, let's say we were always doing the sentiment analysis, we could fine tune the model. So we could permanently alter the model against the examples to long term have better stability and better ability to use this use case. But that could potentially be a good amount of work to fine tune the model. That's a little bit more heavy lifting, and takes more resources, etc. Oh, ChatGPT says if you want, I can refine the model to better detect constructive insights. That's usually where the most business value is hiding. But then data analysis limit has been reached. Oh, I only did this today. Yeah. But that's sort of what I was saying is like we could fine tune the model to end up with to end up with the free, or sorry, to end up with a altered model that works good against this use case. We could do that. If we give data and everything related to data to GPT, write a prompt for that, and then we specify the data should be stable in all types of AI models. That might be You could give it a try. That might be okay. I don't know if there's any guarantee that will change your results necessarily. Um, but so yeah, let's see if we follow up with this and say, I want to improve the categorization, especially so that it's stable across all language models. So this is a good suggestion. So yeah, like what you were saying, we can force a structure. So you are a strict classifier. So we give a role to the model. You're a strict classifier. We want to determine a sentiment, positive, negative, neutral, and if it contains a suggestion, yes or no, sentiment, suggestion, final category. Suggestions override sentiment, classify as constructive. So anything with a suggestion becomes constructive. And then be conservative, only label positive and negative if clearly expressed. So we have a little bit of rules here, and then we output everything into this kind of dictionary. And then we um, it also suggests having examples, right? A small labeled data set of examples. So it's kind of combining having a stricter prompt with some rules, but also having examples. It's a lot of details here, but essentially those two things can make it more steady, is what it says. Okay. But yeah, really good thought to ask the AI, what does it think it should do to make it more stable? And that's kind of what it says. Use examples and maybe make it more structured with some rules in the prompt. So rather than just say, hey, classify the feedback, we have a bit of a more structured prompt to attack that. Okay, perfect. Great. So that is that demo. Was there any other further questions? Really good ones. Any other further questions on that one? Okay. So let's continue along and explore some GPTs. So this is going to be interesting where we want to take a look at some fine-tuned models. So we're just talking about fine-tuned models a little bit. And we're going to explore some of those fine-tuned model capabilities. Now, remember, the fine-tuned models are ones that have been trained against specific data for specific use cases. So they've been updated from the basic existing level of ChatGPT and trained against additional data to be used for particular uses. And so we're going to try out some of those. Um, Now, this table here, by the way, is a little dated. Obviously, we are on the 5 series today. So this was created a little over a year ago. So back then, we only had the 4 series emerging. At the time, the default for the free version of ChatGPT was the 3.5. Much more limited, especially its context availability, much fewer tokens. So where we are today is, much larger than this even. Um, and of course, we can use it for many different complex tasks as we're finding out. But this is a comparison of kind of the older models to see where it has evolved to. And of course, where we are today is just in the 5 series, just really, really massive model that has gotten faster, has basically every one of these areas has improved. It's gotten larger, has more context length, has gotten faster to process for sure. Still doing really complex use cases. Can do thinking, so it's optimized for various things like thinking, or it has its alternative version for efficiency, and certainly can do multimodal. But this is a comparison to kind of the older one. You can see like all the way back in 3.5, it couldn't actually work with images, right? It wasn't even multimodal. Only in the 4 series did that get introduced. And of course, we're in the 5 now. So again, thinking about use cases like summarizing a research paper, if you want to go into detail, you probably want to use the thinking models that we have today, which was aligned with more of the 4 series back then. Or if you want it to be really, really fast, you want to use the fast model, which does less thinking, um, and doesn't handle the context quite as deeply. Um, uh, so um, all that to say is like you can use different variations on the models today depending on what kind of tasks you're doing. So if you're doing something really, really complex and you need all that context, then the thinking model can be very good. If you just care about speed, you want an answer really, really fast, you could just use the fast model too. But this chart is a little dated, admittedly. Obviously, we're on much newer models today than these guys. But you can see some different examples from like the same prompt, explain polymorphism to me in a line. You can see there's some differences uh, um, across the models. They don't all produce the same exact words. They produce slightly different words. And we see that even from like platform to platform, or I should say model to model, right? Like they're not always guaranteed to produce the same exact thing. And it may take different time to do that, depending if you're using one model versus another. So again, no guarantee in the exact same output, no guarantee in the exact same timing. They can take shorter, faster, it just depends. Okay. This leads me to the discussion of custom GPTs, which are, again, these are fine-tuned that have been produced by the community and are available to everyone to use. So people have taken the time to use their own data and to kind of customize the GPT for particular use cases. And they usually have a description of what the GPT is used for, or what its special use case is. Um, and so we'll take a look at that when we get into the demos. But there's a bunch of different GPTs out there. So there's ones for creative writing, there's ones for programming, there's ones for productivity, ones for education, research, like um, educational research, like scholastic research. Um, so these are just to name a few. There's a bunch out there. And again, these are taking the base GPT and fine tuning it against data so that it's been kind of specialized to that use case. It's a little more leaning towards being good at that use case because it's been adapted for that. And this is what a lot of people do. They take the basic GPT and fine tune it. You can pay to have that done by OpenAI. You can upload your own data and they can basically fine tune it for you, and you get a customized GPT. A lot of people have done this. I've seen examples of this for a bunch of different use cases. Um, yeah, there are some of them are. We're actually gonna do some demos with some of the specialized ones for sure. They're kind of like the Hugging Face spaces in which they're like the community GPTs that people can use. Yeah. It's kind of like Hugging Face spaces in a way. Like anyone can use it. Yeah. So I'm gonna show you those and how to get to those coming up in a moment. The first one we're going to look at is the write for me, where they have basically tailored the baseline GPT. So they fine-tuned it to be used for personal writing and creative writing. So it crafts tailored content, focusing on SEO, audience needs, and really creating like creative writing material. So it's geared towards writing. That's what it's really good at. It's been fine-tuned to do that more so than the basic model. So it has a bunch of data has been thrown at this that emulates creative writing or is using creative writing sources. So it's much better at content generation, editing, writing. Um, so if you have a use case for that, this would be a good GPT to use. We're just going to try that out. We're going to do a demo where we explore the Write For Me GPT, which again is just a customized version of the baseline that is particularly been adapted for writing use cases. So let me go over to that. That'll be in demo 6. So content generation um, for eco-friendly reusable water bottles. So we're going to take a look at that. And we're going to see how to access those something like the Write For Me GPT, which is what we're going to use for this. So we're going to do content creation for eco-friendly reusable water bottles using the Write For Me GPT. And our goal here is to create marketing content for an eco-friendly reusable water bottle company, obviously fictitious, but mainly want to practice using this Write For Me GPT. Um, and so what we're going to do is go to ChatGPT, and then I'm going to show you how to navigate to the Write For Me GPT. I'll show you where those are. It's a little bit different than this demo. This is a little bit dated back to when it was the 4 series, so things were laid out a little bit differently on the website. I'll show you how to get to that now. It's a little bit different, but once we find it, we're gonna copy and paste this scenario and the prompt into it. So the scenario is we're preparing to launch an eco-friendly reusable water bottle made from sustainable materials. Target audience is environmentally conscious individuals who are active and health conscious. Aim to highlight the benefits of our product. Um, and here's our prompt. We want to create a compelling blog post for our reusable water bottle product. Blog post should introduce the product and its unique features, discuss the importance, etc. And this is really important context, right? The tone should be informative, engaging, and persuasive, aiming to connect with health conscious environmentally aware individuals. So let's grab this and then I'll show you where to find the Write for Me GPT. And we're gonna use this in the chat with that. So in order to get to the Write for Me GPT, where you want to go is on this left side under More. You want to go to Apps. So underneath More, go to Apps. See how this apps window pop this window pops up when I click on More. Right below Codex, this pops up and I go to Apps. So let's go to Apps, and it should bring me to this page. So once you're on this page, then you go to the top right corner where it says GPTs, click on that. So click on GPT. So again, it's under More, Apps, then GPTs in this top right corner. GPTs. And this takes us to kind of the repository of custom GPTs that have been uploaded to the community. And this is where we want to search for the Write for Me. And it's the very first one. It's very, very popular. It has 48 million chats. Really, really popular supercharged writing assistant. So we want to access that Write for Me. And you can see its ratings. So it has it's number 14 in writing, 48 million conversations. And then we want to start a chat with this. So we'll click on Start Chat. And we can paste in our prompt, our scenario in our prompt. So one thing I'll point out is, do we need to use this custom GPT to accomplish this task? No. We could have just used a regular GPT, right? That's fine. We could have just used a regular base one. That's totally fine. The hope is that these custom ones have really good capabilities geared towards creative writing and marketing material writing. And so it's worthwhile to use these custom ones because they're geared towards these use cases, like essays, blog posts, any kind of creative writing that we would want to do. So in this situation, we're hoping to create a product marketing blog post. So it's a good fit for this custom GPT. So we send that along and it generates our blog post here. So it has a lot of detail. It says a better way to hydrate, meet your new go-to water bottle. If you care about what you put in your body and your choices, your water bottle matters more than you might think. That's why we created a reusable bottle designed for people who want something cleaner, safer, and more responsible than a single-use plastic. This isn't just a bottle, it's a small shift that adds up to a real difference. So then a bunch of details about why it's worth rethinking, meet the bottle design for real life with a bunch of feature details, health benefits, small change, why this matters, ready to make the switch. Um, so pretty compelling blog post. And what I would encourage you to do is maybe try the same prompt with the baseline model and see how it's different. And it's not to say that what the baseline model generates is wrong. It's just subjectively, the Write for Me is geared towards this task. It's geared towards creative writing. And so it has been trained against a bunch of creative writing use cases. So it can ideally perform better in these cases, but we could see it for ourselves. We could try it out on the just baseline model and see kind of how it works there. And it's not that what that would produce is wrong. Um, it's that uh, it's just different, right? It's just using the baseline model that hasn't been geared towards, um, you know, creative writing. I do not pay. That only showed up because I used this, but as I said, you don't need this to show up to get to it. You just have to. Do you see this more underneath Codex? Do you see the more underneath the menu? So click on more and go to apps. Yeah, then go to apps. Do you see apps? If you click on more, you should see apps. Click on apps, and that should bring you to this page. Do you have that? Okay, once you're on this page, go to the top right where it says GPTs. That'll bring you to the menu. So you click on GPTs at the top right. That'll bring you to the menu of GPTs. So there is where you want to search for right for me. And it's the very first choice. Very first choice there. Show one more time. Yeah, so go to more on this left menu, go to more and then apps. So that's the very first thing you do. Click on more and then click on apps. It should bring you to this page, right? It should bring you to a page like this. Top right corner of this page is GPTs. Click on GPTs. Do you see GPTs? You want to click on that, and that brings you to the menu of custom GPTs. This is where you want to search for the right for me. Did you get to it? Then once you, by the way, once you click on that, then start a chat with it. Start a chat with it. And that's how you can launch that chat. Okay, any other questions on this custom GPT? So we did this, we created the response, or we created the blog post there. Again, one thing we could do is kind of compare it to if we were to, just use a regular model and try it out that way. But the custom GPTs are pretty useful. And I think once, by the way, once you use it, um, I think this menu shows up on the left side for you. So you no longer have to go through that more apps, GPTs, uh, multiple clicks. You could just go to explore GPTs, which brings you to this page. By the way, in order to create your own, you have to get the premium subscription to create and share your own, which would be fine tuning, like using your own data, fine tuning and generating your own GPT and sharing it that way. Um, you'd have to upgrade to the premium version. All right, so one more demo of a specialty one, which is going to be Canva. Now, a lot of you may have heard of Canva or maybe have used the standalone Canva product, but it actually is within GPTs. It started out as a custom GPT. Nowadays, it's its own kind of standalone product. Um, but here it can help us with creative designs from our text prompt descriptions. Perfect for generating like product designs or flyers or posters or any kind of even like PowerPoint presentations, honestly, social media posts. They can be generated from our text that we use in our prompt. So we're going to show a demo here of using the Canva GPT. Um, and we're going to see how we can use that to design content for a coffee shop product. So creative branding makeover for coffee shops with Canva GPT. So we're going to do this demo here, which will be demo 7. So let me open this one. Okay. So again, our goal is to utilize Canva GPT, which is one of those custom ones for designing a marketing content essentially for a new product, the Sunrise Brew. So in a lot of the same ways, we're going to navigate to in the way we found the right for me GPT, we're going to find the Canva GPT, and we are going to copy in this scenario and prompt. So um, our prompt here is to create a coffee shop launch post for Sunrise Brew, featuring warm caramel and chocolate tones with a tagline to highlight its bold, smooth flavor and energy boosting warmth. So here is our prompt. And we're going to navigate to, again, it would be under, by this time you probably have, if you use the right for me, you already have this menu on the left, so you can click there to go to this. You can also go to more apps, GPTs, and then it's actually right here under the featured, the Canva, but you can also just search for it, Canva, and we can start a chat with Canva, and we will paste our um, we will paste our prompt, which is to create a coffee shop launch post for Sunrise Brew, as we said, and let's send that along. So it's going to use generate designs, sure, from Canva. All right, so it generated a bunch of different options for us. Let's see. Uh, Continue here. So here is the first thing that it built. Instagram post, Sunrise Brew grand opening. This looks pretty good. Pretty reasonable. Let's see what option two is. That one looks pretty good. Let's look at option three. Pretty good too. All these look pretty reasonable. Option four, let's look. This one is close. It got instead of this should be Sunrise Brew. So we'd want to edit that, which we can do. So edit that Sunrise Brew, but otherwise pretty close. This is for an opening. Oh, that one's really good. I like that one a lot. Sunrise Brew, we're open. Pretty amazing. I mean, these are pretty good, right? These are pretty good for a simple prompt. Oh, wow. Well, they did a pretty good job with that one. I don't know. I didn't do anything special. Anyone else get multiple? Yeah, I don't know why that. So that one popped up for me. I would make sure you're using the here. I'll paste it. Maybe I would make sure you're using this Canva. I would use this link for the Canva if you can. Make sure it's the right one. It might be a slightly different one. Yeah, there might be some other ones that are called Canva, but this is the one we want to use. Just want to make sure it's the right one. So it generates these different ones. Looks like this in this demo it did four of them as well, or at least two. All right. So continuing our examples here with various GPTs. We're going to explore another one called Designer GPT, which helps with code review, programming, uh, um, uh, code generation. So kind of like a coding assistant in some ways. This one is designed for that. Um, sp Particularly HTML web pages, things like that. So designing kind of like web design is kind of what it's meant for. So we will do an example with that in this demo, creating a website design using Designer GPT. For you, it's generating an animated post. It could just be. That just could, are you talking about Canva? It could just be that's the direction it took it, is creating an animated poster. Um, not everything is going to be, not every creation is the same. So it's just, I don't have a good explanation for why it is. It just is, you never know what you're going to get with generative AI, right? It could be different each time. So if you run it again, you might get something more static. So don't have a great explanation for that. But I'm going to go to demo 8 and let me, all right, creating a website design using designer. Yeah, could be because of that. Okay, so we're gonna use this designer GPT to create a website design or product landing page for an online store. So we're gonna look for the custom designer GPT in the same way we've been working with the other ones. We have our scenario here. So an online store wants to create a visually appealing website, and our prompt is provide a design concept for a website or a product landing page for an online store. Design should include a header with the logo, a navigation bar, a hero section, sections for product details and testimonials, and a footer. Design should be visually appealing with a balanced color scheme and clear typography. So this is our prompt, and we want to put this into um, the designer GPT. So if we look for that one, designer GPT, there it is. So we want to go to that one and start a chat. And we can paste in our scenario and our prompt and send that chat along and try to produce um, this website design. So let's see. So it says, before I generate a full website, do you want me to use DALL-E generated images or unsplashed images, high quality stock photos? Let's do use DALL-E generated images. Let's tell it to use that. And thank you for posting the feedback link. If you guys want to do that now, you definitely can. We could also wait till the end, whatever works for you. But this is the designer GPT asking us what kind of images we want to make. It's going to make an image here to be used with the website design. So it's asking us if we like this. Um, sure, we could say, yes, this looks good for the visuals. Yes, and then it will generate the HTML landing page. So it's going to use that image we built as the inspiration and part of our basically part of our website code that will be the HTML code that will be used to create the website kind of layout, and that image will be kind of the inspiration for that. So this is what the website looks like. Looks exactly how we uh, um, kind of generated that image. So it generated everything for us here. This is obviously a fake product. So in reality, we want to provide all of our details in the prompt, like all of our product details, different details about what we're looking for in our website. But it kind of looks like this generally. Um, and so, uh, so there's the HTML, and we can uh, download this or view it, the actual code that generates this. Um, but this is what it kind of looks like. It's pretty interesting. The publishing would need to be separate. Yeah, it's not doing the publishing for us. That would need to be done separate, but it's creating the design. So this is the HTML code design that we would then use to build our website from. So that publishing part has to be done separately. Yeah. And then we can ask it to export it too, so we can get the full HTML code, so we can edit this if we knew how to do that and wanted to do that. That's something we could do. Sorry you reached the limit. Yeah, that's unfortunate. I mean, we're almost done with working with the GPTs, so just hang tight for now, and we'll see. Just kind of observe some of the demos, and then you can try them on your own when the limit resets. There are, if you go to Gemini, they're called gems. So if you go to in Gemini, do you see the left-hand side where it says gems? There's custom models over there. So if you go to Gemini, you should be able to see the gems, and then you can look at, you can explore some of their pre-made ones. Um, these are pre-made by Google. Um, So they have a brainstormer, career guide, storybook, play chess, learning coach, writing editor, which is kind of like the right for me. I don't know if there's a larger um, marketplace here. Not as extensive a marketplace, I don't think, as the GPTs, which are kind of from the community. I don't see those. I just see these pre-made ones from Google. Okay. Let's try another example. Let's look at consensus. So we'll look at consensus, which is for academic research. So consensus is mainly used in the academic research community because it's been trained against kind of a repository of a bunch of different academic papers. So you can get kind of interesting answers to questions that synthesize a bunch of context data that it's gathered from all that research papers, providing concise summaries and responses to questions. So, really interesting GPT, and we're going to do a demo with this one. So, we're going to use the consensus GPT for research analysis to conduct a literature survey on the impact of large language models and on NLP or NLU, natural language understanding tasks. And what it's going to do is synthesize all that research on this topic and basically provide um, some insights based on all that academic research around this task, around natural language tasks. So we're gonna do this demo, which should be demo 9. So let's do that one. Again, if you've hit your limit, unfortunately, you may not be able to do it. That's okay. So we're going to go to the Explore GPTs and search for the consensus GPT, and we're going to utilize that one. And we're going to use this scenario. So scenario is a researcher conducting a literature survey on the impact of large language models on NLU. They aim to gather and analyze recent studies that explore advancements in LLMs, particularly in areas such as question answering, text summarization, sentiment analysis. And so what our prompt is to analyze key trends and challenges in the field, discuss the role of fine tuning and transfer learning. So that's something we've talked about in this course quite a bit. Transfer learning, right? Starting from a model. That's actually what all of these custom GPTs are, transfer learning models, right? Where they have started from the base GPT and have expanded, beyond that by training against new data to create this custom GPT. In this case, Consensus is trained against a lot of academic research papers to provide answers that are kind of grounded in that. So let's find the consensus and send this prompt along. Again, you could try, like, even if you can't run this now, you could try it later when the limits reset. Hopefully for you, they um, reset within a day or so. So consensus, start a chat. So there's our prompt, conduct a literature survey on the impact of large language models on NLU tasks. So let's see. Consensus wants to talk. Allow. So then it gives us a bunch of background information. It says literature survey, impact of large language models on NLU. Large language models have significantly advanced natural language understanding, such as question answering, text summarization, sentiment analysis. Um, and there's a bunch of now what's really cool is they provide links to those papers. So inside of their responses, they have hyperlinks to those, which is really good, and good kind of citations throughout. That's what you get with consensus, which is really awesome. So it has sentiment analysis, text summarization, question answering, the role of fine tuning, adapting general knowledge to specific tasks, something we've talked about. Um, and this is something I talked about the other day, is making it more efficient, PEFT, because fine-tuning a model is very expensive in the language modeling landscape. Like it's very, very expensive to do that. So luckily there are methodologies to do it in a very efficient way, that isn't a full retrain of the model. Uh, um, Wish I had this. Yeah, me too. Me too. Agreed. Really cool kind of summarization of research papers, which is nice. Oh, I see the question about our NLU. Yeah, pretty much the same. Um, I think the difference is that a lot of people use NLU to be more of the um, uh, ta like a subset of the tasks that we usually associate with NLP, which is kind of a broader subset of tasks. Like text generation would be more NLP, but understanding is usually like a classification, um, almost almost like a sentiment analysis. It's so understanding is more of trying to synthesize the text, and learn context from it, whereas the processing is more generating something from the text. So we have more understanding it and then generating something from it, which is the text generation piece usually. The understanding is kind of the trying to learn context from it. So kind of what like the large language model does is more understanding. Then the output of it though is more the processing, like generating the probability of what should come next as more of the processing. But yeah, they're very, very pretty much overlapped, very similar. We have an AI. Yeah, yeah, because yeah, so that would be like understanding audio and language to synthesize that into some type of response. Yeah, for sure. So this is really cool in terms of consensus, right? A lot of interesting insights we can gain here about any kind of topic that we're interested in. We get a lot of links to papers that we can kind of pursue and read. So very, very useful in academia for sure. Okay, very good. So we did that one. So we saw consensus. I think we have one more. So we have one more custom GPT that we'll look at, which is the universal primer. Now, this is one for tutoring mostly, educational content, tutoring, teaching. So this is a helpful one for learning, just generally learning about topics and subjects. So we are going to imagine we were kind of a student and we wanted to learn more about like chemistry. We can explore this GPT to help us improve our understanding of these topics. So see how it can be used as kind of like a tutoring tool of sorts. So let's go over to this demo 10. So demo 10 here, universal primer. Okay. So we're going to basically search for this one in our Explore GPTs in the same way. So we are imagining we are a working professional with a background in engineering, preparing for an important project presentation that involves understanding chemical equilibrium principles. Despite his experience, Alex struggles to grasp how changes in pressure, temperature, and concentration impact chemical equilibria. According to Le Chantelier's principle, he seeks a straightforward explanation with our Chatelier principle. He seeks a straightforward explanation with real-world examples to deepen his comprehension. So just wants to learn more about this topic that isn't known, we might not know much about. So we can go to this kind of tutoring GPT Universal Primer and learn more about it. So let's go to our Explorer and look for Universal Primer, and we'll start a chat. And we will pa paste in our scenario and our prompt. So what's cool is it's going to tailor this to our background. So let's build this in a way that clicks with your engineering intuition. So let's think, so it breaks it down, right? The principle, we think of it as a self-regulating process unit, a reactor that is settled in a steady operating point. At equilibrium, forward reaction rate equals backward reaction rate. Macroscopic variables are stable. Now imagine this system has a built-in feedback controller whose only job is something disturbs me, I will shift in whatever direction reduces that disturbance. That is the principle. So another analogy provides another analogy. Um, Concentration changes, add more people. What happens if you add more reactants? You suddenly dump a bunch of people into the left room. The system responds, move more people to the right room, more forward reaction until flow balances, system shift to the right. Remove, you open a door, let people leave, more people leave from left, right, you should refill the right to balance it. So it's all about balancing. Um, so Pressure changes, shrinking the room. This only matters for gases. Think of it as compressing it. So all of this knowledge, we may not know anything about chemistry, but the universal primer is a good GPT that's been tailored to do tutoring, essentially teaching and breaking things down effectively. So this is a good one for those use cases, right? Breaking things down, having a lot of analogies and examples in the explanation. And that's because, again, this model has been tailored to this use case. It's been shown a bunch of examples to do this use case. So very detailed response with a lot of uh, uh, it even has questions to check understanding at the very end. So for the reaction, what happens if pressure increases? Why? Um, all kinds of questions to kind of check our understanding. So really, really cool tutoring assistant here. And what I would do is if you know when you if you hit your limit, fortunately you can't run this right now, but maybe give this a try on your own. Maybe ask it about something you really want to know about. It could even be related to LLMs. It could be related to generative AI. Anything we're studying here, you want to know about more. This might be a good one to try to use to learn more about that. Okay. Any questions on this one, the universal primer? See some really cool GPTs out there. Of course, there's a lot of them, and you can explore some of them here. Um, there's a logo design, so a lot of like image generation ones, education, um, learn English, finance, helps you with everything business, finance, knowledge, academic assistant, a lot of interesting ones. Okay. All right, let's go back to here. All right, so let's continue forward. So we'll talk about eventually, doing some more workflow automations. Let's talk about the impact of generative AI, generally on the industry, and it's really had an impact on so many different domains it can reach, mainly because of its ability to understand so much and help humans and automate things and make things faster and do things for us, like take action, especially with agents that are powered by LLMs, but take actions and do things. We see a lot of impact across so many different domains, more than just what's on this list, but these might be relevant to us. Um, so what we're going to do is explore these different areas by looking at generative AI tools. So we're actually going to look at various generative AI tools that are used in the industry for these different domains. Um, uh, and that's what we're going to do to kind of finish out the lesson is some more demos, but of where generative AI has helped in these various domains. The first place we're going to look at is workflow automation. So this may be something you're familiar with. You may have worked with some of these before, but these are generative AI powered software or powered tools to automate repetitive tasks, such as auto-generating CRM support tickets, maybe automating email campaigns, automating IT support tickets, and things like that. So just general kind of workflow automation. There's so many tools out there. Here's a couple popular ones. We're actually going to do a demo with Zapier, um, and we're gonna actually see how we can set up a automated workflow using Zapier to automate kind of this marketing workflow of generating like CRM leads, which may be like a tedious manual task, and we can actually automate that and just see an example of where that can be used. A tool like this could be used to automate things. So we're going to walk through it together. And this isn't going to use ChatGPT. It's actually going to use Zapier. We're going to make a free account there and practice building a what's called a Zap, which is and basically a workflow automation. So we'll do that together. So let me go over to that one. So this will be demo 11. As I said, lots of the demos today. Okay, so demo 11, we're going to look at Zapier and creating a Zap which is a workflow automation. So we're going to go to Zapier.com and sign up. So we'll do this together. So we'll go to Zapier.com. and we will sign up. And you can use an existing Google account, which is what I'll do. But feel free to use whatever account you want to use. Um, but it's free, just free to create one. But you want to go there and do that. You can feel free to enter your own personal email or use Google or Facebook, Microsoft, whatever you have available there, to log in. Once we log in, we want to choose your role, select, so that could be anything. So we could just pick, um, we just pick data science, I suppose, or marketing. We could pick either one. Actually, let's just do marketing for this. What's our company size? We could make it small. Doesn't, these don't really matter too much. These are just informational. We could even skip these. Uh, Select the option that needs to be automated. Select the apps you want to use. Again, I think we could skip these. Just me for this. Okay, so individual contributor. I'm going to skip this for now. Okay, so we are here and we now can go to, if we follow the demo, we can go to create Zap. So we want to go here to create and we want to create a Zap. So click on that. So once we have done that, we want to click on trigger. We want to select Google Sheets. So we're going to select an automation that's based on Google Sheets. So this would mean like something in Google Sheets is being changed or added, which will trigger the Zap. And it gets triggered whenever there's a new spreadsheet row. So whenever we add a row to this spreadsheet, it's going to trigger so new or updated spreadsheet row, or we can just do new spreadsheet row. And we will click on account and select the Google account. So pick your Google account. So I will just use this one here. Okay, so we have done that. So we're setting up the Zapier. So before going to the next step, we'll go to Google Drive and we'll make a fake spreadsheet. So that because what we're doing is we're setting up an automated workflow. So we need some fake data to work with. So we're going to create a fake spreadsheet with the name lead. Um, and um, then we will, so let me go over to this and make a new, um, sheet and we will call this lead example. And let me go back to the demo. See what that picture says. The picture is more rendering in my file for whatever reason. Lead data sample. Okay, I called it lead example. I don't think that matters too much. And then we can select continue. under spreadsheets. Okay, so now this should be able to find the spreadsheet. So we can pick lead example, sheet one, sheet one, and then we want to fill in the sample data. So we want to fill in an example there. So we will fill up a sample data. Um, see what the format of it wants. So it looks something like this. So we have a name, an email, and a plan or a phone number here as different rows. So we could just add some fake rows in here. Um, and then so we have name, email, phone number, name, email. I don't think this matters too much what you put in here. It's just to test our automation. So we're hooking up our automation to this spreadsheet. So just put in some, and then phone number 1, 2, 3, 4, 5, 6, 7. You can't select a file you just created. Make sure it's the same account. Was it the same account was it created in the same drive as what you have hooked up to Zapier? Huh, maybe try making a new one. I don't know why that wouldn't be available. Jane Doe. I'm just making a couple of fake examples. So Jane Doe at email.com. And then 789 1, 2, 3, 4. Okay. All right. So some fake examples there to put in. Now click test trigger to show the row data on Zapier. So we should see so we should be clicking the test trigger button to show the row data. And it should display some of that information. So we click test trigger, unable to pull. So it found two. So it had two rows. Sorry, it has two rows, row A and row B. So that was able to find it. So, and see how it has some of this information, row ID, row number, name, email, phone number. This is the data I had from that spreadsheet. So it was able to, this just tests that it was able to pull in that data. Oh, that worked? Okay, perfect. Yeah, I had to run it twice. I had to run it twice to do that. So it found those two rows that I have there. So that's pretty promising to be able to find those two. So click on action. So what we want to do is in here, we want to, so now we have our spreadsheet hook up to our workflow. So what this should mean is anytime a new row is added to that spreadsheet, we want to do something with that row. So now we're going to hook that up with an action and we're going to hook up Gmail to that. And so what our intention is so we pick Gmail. in the action. And under event, we want to do send email. So we want to send email. And then we want to, I imagine, connect, continue. We want to connect the account. Okay, so we have that. We hit continue. So now this is where we want to enter. Now this is where we want to grab some of the data from our row to populate into the message that we're configuring to send. So we're going to look for the email, which is email. So we're going to grab that email, and that's where we're going to use the to here. Select the data from the sheet, which has an email ID. So we're grabbing that. Select further action fields that you want to automate as shown below. So we want to generate a subject. Um, and then we want to uh, so we want to change some of these things. So some of these things we could change. We could add a CC, a BCC. The from should be obvious is from our own email. So the required things we have to do is a subject. So we could add a field. We could add their name, Jane Doe, new product, launch. So we're just populating some data here in our subject that involves the information from our spreadsheet. So this is why this is kind of an automation. It's using data from the spreadsheet to automate sending a bunch of emails like this. Um, here, inviting you to our new product launch. Um, we could even add in information here, like the name, email, phone number, whatever we want. And then we can add a signature, we can add attachments, we can send a message to Google Contacts group. So a few other things we could do, not too concerned about it. But that's pretty much it. So we can configure this email, and then we can kind of um, test this step. We have a bunch of empty fields. This is kind of what the email looks like. It's to this address, from this address, new product launch subject, body is like this. All these other fields are empty. So this is just kind of sanity check what this is going to send. Um, we could test it. We could skip the test. I'm not sure if we need to test it. I don't think so. Test up. Okay, we could. Zapier will act and an email will be sent to the lead who has filled the form. Click on publish. Um, and we will have our Zap created. So let's do a test. A message was sent. So it looks like that test worked. So we had some IDs here. So, and it was sent. So that worked. Okay, so now we are ready to publish our Zap. And now our Zap is created. And so just to summarize everything here, whenever we have a new spreadsheet row, this will trigger this event. So it will trigger an email to be sent, which is exactly what we wanted, right? So now what we should be able to do is go here and add new contact and then new at email.com. and then whatever phone number, 123 um 9876. Um and so once that new row is added, that should trigger our email to be sent here, and I want to make sure we can track that Zap runs. You just have to, yeah. So I don't know if there's any templates out there, but you can create Zaps that hook up to Slack for sure. Um, yes, you can hook up to Slack and then you can send a message. So in the same way we just created the Zap, you can go through and create one that hooks up to different apps. Yeah. I don't know where there's good templates for those, but you could practice building them in the same way we kind of built this. You just would be hooking it up to a different app. So this one should be, okay, that's kind of weird. I would have thought it would have ran, but maybe it's a little delayed. Oh, there we go. It just ran. It just ran just now because we added that row, right? And we can see the run here. We can see some details about it. So we added this new row and we can even see what happened there, right? So if we have we had a new contact name, we had a new email. That was the new row we added, and it sent the email. So it sent this email from this automation. So pretty interesting, right? It's actually working. And we can see that it ran because we added a row to this sheet. So obviously a very basic automation, but all that's being done, and like you can hook up different apps to this. So Slack is a good one. You can create new Zaps that way. Yeah, it is like so if you pay. That's a thing. Like if you pay for the premium Zapier, they then you kind of have a license for to work with them. And I don't think they store your data or anything, or it's locked down. That's their guarantee is it's kind of locked down. It is a risk though. It is a risk that you're opening up your apps to kind of a third party AI tool. We talked about that before, right? That's a security risk because you're sending your data through them. So there's no guarantees necessarily, but that's something that they kind of claim is that it is safe. But it's a good question. All right. Potentially, like if you I know people who do use it at their work because they've paid for the premium version and there's like a basically a license to use it with the data that it is basically like a privacy agreement that none of that data is being shared. So I think yes, you can. You just have to pay for it. You have to enter into kind of a license agreement. Different tools that can help us with generating video content, especially like personalized video content. And so we're going to look at one of those examples called in video um, in this demo. So we're going to see how we can make a video for a marketing initiative. And we're going to use the in video tool to help us do that. So let's go over to that demo here, which is demo 12. So I already have that one pulled up here. Our goal here is to utilize NVIDIA to create a video for marketing use case. So we're going to go to this website um, and uh, explore this tool. So I believe we will have to log in. So we'll have to log in with a Google account or create your own. So just add that information. Um, Marketing. Okay. All right, so we are here. Again, you just have to sign in to get to this page and answer a couple questions. So you can create a free account. This is all free. I'm not paying for any of this. Obviously, it's just free account. Once we are in here, we will add the prompt. So we're gonna add this prompt, importance of Gen AI in sales and marketing, and we're going to generate a video based on that simple prompt. So, importance of Gen AI in sales and marketing. Obviously, this is a prompt that could be as detailed as we possibly want it to be, just like any other prompt we were using for like GPT or anything else. So, but let's just do this one: importance of Gen AI in uh, sales and marketing. So, just like that. Um, then what we want to do is submit this. I think we want to think the agent. Let me see. Yeah, so maybe we want to go to autopilot. We don't want the agent mode, I don't think, for this. So back then it looked a little different. I think we just want the autopilot mode rather than the agent mode. So it's going to launch and uh, churn on that to create a video. So the thing we could think about with videos, and I've said this before, is, it is a time sequence of images. So really what a lot of these are doing is really generating a bunch of images and stitching them together in this rapid sequence, in this rapid time sequence. Is kind of how they approach building videos. And so you can imagine there's a lot of combination of model components that we've seen before in deep learning. So things like um, transformer elements to build those images, or diffusion elements to build those images. Even things like RNN elements to build a sequence of images that is our video. So we can decide what platform we want this to be on, the length of it. So let's just say a minute and a half is fine, just basic. What platform we want this on. Um, Maybe for YouTube, that's fine. And then generate. Don't think it really matters what platform it is, but Speechify is doing speech to text. Yeah, I think there's a lot of examples of speech to text out there. Everybody seems to have it. Like I know Notion, if you've ever used Notion, Notion's AI does speech to text. Um, Zoom does it. So many people do it now. So this is putting together the video. Obviously, takes some time to generate a video. It's just generating all those images, lots of them that have to go in a rapid kind of animation sequence. Um, so it does take some time to do that. We also had a relatively vague topic. I think if we had a little bit more specifics, we could it might be easier to generate in some ways. Let's see. So select the workflow, generate a video. That's what we're doing. So we're on this page. It's kind of what we're doing. This is the reason these images look a little different. This is back, they had a different workflow to building the videos than they do today. This was from a couple years ago. Probably needs to be updated. Okay, so we'll let that run and we'll see what it generates. This one in the demo, it looks like it generated something like this, about a 2.5 minute video, and we can export it and download it and watch it. But it looks like it kind of looked like this. So we'll see what ours looks like when it's ready. It's still only sitting at about 7. It's moving now. It was sitting at 5% for a while. It's going through scene generation, which is interesting. So it's sitting there, really planning out. Yeah, Otter. We can jump to. We should be able to make it to that. We'll see. Might not be able to get to it today. Might have to run it on Monday. We'll see if we can get to that one. But we can jump to our next one while we're waiting for this. So while we're waiting for the video to generate, we can discuss software engineering use cases. So this is a big one. So especially today with the use of like coding agents to help us generate code, to run tests, things like that. We're going to take a look at using the um, we're going to take a look at using this tool, Uizard, Uwizard, which is like a wizard for creating a UI. But obviously, there's so many coding tools. Uh, um, is there any way to search specific AI for a use case? I mean, other than Google, not necessarily. I don't think there's not like a good repository of these things. Um, but you're gonna have a lot of options generally for these generative AI tools. So it's a matter of like exploring them to some extent and picking the best one. But no, I think it just kind of web search to find whatever use case, whatever tools are good for your use case. Are you talking about with coding agents like struggling with all the restrictions? Yeah. Yeah, I think that's I've heard a lot of mixed things about coding agents in particular is that some places are really strict about using it and not using it. So there's I've heard a lot of stories from different companies where they've had like horror stories of generated code from agents kind of backfiring on them and deleting things or like producing bugs and bad code that ruins user experiences. And so a lot of places are cautious about using it to some extent. But I think there's a happy medium there of being able to use it to help with tasks, but still, um, you know, help with tasks, but still be somewhat cautious and not just completely have AI generated code dominating all the code bases. So I think there's a medium ground there. Yeah, of course, that's a concern. Yeah. No, I get that with trusting third-party code that because all of these agents are trained off of open source code bases like a GitHub that you never know where that's coming from. So, no, I totally get that. Um, so yeah, that's that. Bottom line is not everybody's able to use it to the same extent. Whether that's like a self-imposed restriction at the company level or just because of requirements, kind of what you're saying. Um, all right, so let's take a look at this demo using Uizard, which is a UI generator. So we're going to see how we can craft a visually appealing user interface that is for like an e-commerce platform. So we'll be using this Uizard. Our video is still sitting at about 36%, so it's chugging along. Definitely taking some time, but that's okay. We'll go to our next demo here. Let's go to demo 13. Okay, so demo 13, designing user interfaces. So we are going to look at the Uizard uh, platform for generating a UI design. So we'll go to uizard.io and take a look at that. Oh, I think our video is done as well. So I'm just popping back over to the video before we do that. Let's see what it generated.
Imagine an assistant that writes your outreach for you. It instantly scores.
Just meeting that. So it just looks like an AI generated video, doesn't it? Which a lot of people get turned off by these days anyway. But there it is. 2 minute. Actually, it is about 2 minutes. Looks like it's reusing a lot of the same images kind of over and over again in the video. And then it has that at the end. So obviously, if you have the premium version, I think it removes that. But we don't have the premium version, it would remove this, and we could actually use it. We had a very generic. The problem with this video is we had a very generic prompt. So it's just importance of Gen AI and marketing. It's a very generic topic. It gets made better with the prompt. Obviously, we include more details in there. We get a more detailed video, but just proving out the concept that we can generate videos, using AI, which is interesting and we've seen it be prevalent across so many different spaces like social media and even in commercials that we see on TV. A lot of those are starting to become AI generated, which is, I think, much to people's dismay. They don't usually like those, but we're starting to see it more and more. Okay. So we're going over to Uizard. I'm not sure how to pronounce that entirely. But we will sign up for free so we can practice making a design. So we'll click on that and we'll sign up with Google here, but feel free to sign up however you would like. So accept the terms. I don't want to receive any news. Usual thing, they ask you about things. Um, Personal design, skip, uh, Google search, website. Again, just more informational questions to get you started with. Skip, be free. Okay. So we finally made it to the main landing page after going through that. So we entered all this information. So we want to do a new blank project and click on web to create this. So we want to do a blank project and we want it to be, I suppose, desktop web. So we are doing that. And then what we want to do, click on screen and click on generate screen to get a new home screen to design the project. So click on screen. Okay, so we are there on the screen and we can click on prompt to generate a prompt. Trying to find that. Maybe it's under, oh, here. Okay, auto designer at the bottom. Generate screen, type a description. And it is for desktop. Okay, so we can provide our prompt. Use the following prompt. So an e-commerce product showcase page. Just want to do that. So again, I got to this just by clicking the bottom, the auto designer at the bottom, and then went through the little buttons to select generate screens, and then type a description, desktop for a desktop application or a website, an e-commerce product showcase. We could do creative. Don't think this matters too much. Let's just do creative. It's generating multiple screens here for us. So just kind of like before with the Canva, generating multiple options for us here. Anybody able to get to this point? Were you able to find the auto designer at the bottom? Might also be able to get to it, by the way, by clicking on this magic on the left. Okay, so our options are almost done here. Okay, so it gave us a couple options. We can just pick one, doesn't really matter. So let's just do this one. So there's our screen. Um, Perfect. So there's our initial screen. You can click on share, export, or preview from the tab. Click on screen, click on wireframe to upload hand-drawn sketches, click on import. So you can do it in multiple ways. So you can generate a new screen from like a hand-drawn wireframe sketch. I'm not gonna do that because I think it'll take me too long to draw something like this out. But you could do it that way too if you had a wireframe, which would generate kind of the screen like that. I think the prompt is likely the way most people would go there to provide a bunch of details. But that's just one way of kind of generating the design. And then what you can do is go into each one of these elements and edit it. So you can change its border, style, design. So again, this is all part of the UI design here. Um, and we can change up all these elements. So this can get us a nice kind of prototype of what our website might look like or our UI for an app because it can do mobile, it can do, various different things. One thing to realize though is with the free version, like we just generated this one page and it's already used up a lot of the elements for a project. It's already used up 150 elements on the screen. Um, so almost at about half of what we're allowed to use. Um, but so, but that's okay. It looks pretty decent. We can change various things, but uh, looks pretty good. So that can get, and that's for like if you are doing UI design. I realize not everybody might be doing that, but just one tool to do that if that's something you're interested in and something that you do is an app like this. There's a bunch. There's a bunch of UI design tools that are out there. This isn't the only one. Just an example of what we could do. A lot of it is prompt driven though, right? So you want to, it's the same thing with any other prompt. You want to make sure you have your details in there so you end up with kind of something that you really want in the output. So this is where we left off in the lesson two Gen AI literacy slides. We had been doing a lot of demos previous to this, doing using just exploring some of the tools that were out there. So that's what all these previous slides were. We're kind of just introducing different tools that we could potentially use for, different tasks. And we had a couple more that we hadn't quite got to it that would be worth just checking in on those. And the one of those application areas is data analytics, which is very relevant for us because we did spend a lot of time going through how to do some data analysis in Python, right? It's particularly in Pandas. Um, but it's actually possible to automate some of that with AI. And I'll show you one example of doing that with the Julius tool. So we'll kind of look through that and do a demo of that. But um, yeah, this is going to be, an example of doing some basically examination analysis of data that we've been able to do ourselves with our Python code, but now we can kind of uh, automate some of that to a degree. Not every single thing we've done, but some of the basics we can certainly just kind of prompt about a data set and get some insights about it very quickly, which is nice. So we're gonna do a demo using the Julius AI tool. And really what the demo is going to be is just uploading any data set that we have and then kind of asking some questions, some basic questions about it, like which kind of align to a lot of the things that we would do anyways if we were, loading this into Pandas and then looking to do some things with it, which as I said earlier, we'll kind of review. We'll actually review that because it's been a while since we've had to do that manually. So we'll certainly spend some time reviewing that, but this will help kind of automate that to a degree. So I wanted to go over to the demos, which is going to be demo 15. So if you want to take a moment to pull that up, that is lesson 2 demo 15. We had a bunch of them in lesson 2. This is demo 15 called data integrity using Gen AI. Um, and we're going to explore this Julius AI tool. And again, by no means is it the only tool that can do something like this, but just kind of exploring it a little bit. Um, and it says here to download the customer CSV from the LMS, but I don't think it matters really which one you use for this. We can use any kind of data set. It's mostly just to explore the Julius tool a little bit, and so work with it can work with any data. It doesn't really matter what it is. So I'll pick an older one that we have, for instance. Um, but the first place we're going to start is going to Julius AI. So we want to go to that website and take a look at it. So it's this website here. Um, and then I don't think we don't need to sign in or anything. I think we could just start a chat on the homepage and it should take us I think this is our old one, but right here you can kind of see um, you know, the main chat interface is just right here on the Julius.ai website. And this is where we have an opportunity to upload a data set. So we can click on this button. Uh, we do have to sign in, so I'll just sign in with Google in order to upload, it looks like. And what we want to do is upload a data set. So I'm going to pick a file that I have. It doesn't really matter what data set we use. I'm going to use one of our old ones, which is the credit card CSV. So I'm going to look at that one, which was an old one we used from clustering, so credit card general. But again, it doesn't, we could use any data set here. But once we upload that, we can ask a bunch of questions. We can ask a bunch of questions about it. So what's cool is when I put that in, it kind of it shows it to us here off to the right. So we see some of those fields like customer ID. We had balance frequency, purchases, um, all kinds of different fields here. And remember, this is data that we actually did dimensionality reduction to, and we did some clustering with as well. And we did that a while ago, but I'm just using this here as an example. Again, you can feel free to upload any data you want that, we've used for previous demos, for example. And so uh, we can ask some questions about this. So we could ask something along the lines of do a basic data uh, integrity check, such as for duplicates, missing values, um, outliers, uh, um, so missing values and outliers, and give a report on the data integrity. So just asking simple questions about this data. We want to, these are things that we would do, manually for the most part. And we'll go back and take a look at that. We'll go back and take a look at that, how to do this stuff manually, just to remind ourselves. But certainly we can ask questions about it. So we're asking a question there. And you can even see what's interesting is what it's doing underneath the hood is running a lot of the code that we would be building manually in order to process this. So it's interesting, right? It's actually generating a lot of code itself in order to do this analysis that we would have to do manually. Um, and so we can see we checked for these things, duplicates, missing values, outliers. It gave us the shape, so how many rows, about 8,900 rows, 18 columns. No duplicates, so they look good, but there is missing data, 314 missing cells, which is a low percentage, but still. Only two columns have them missing. The credit limit column had one missing, and minimum payments had 313 missing. Of course, we could find that out ourselves, right? And what's interesting is generative AI is kind of underneath the hood, analyzing this data and using some tools essentially like writing. You could even see it. It's kind of writing the Python code that we would have to do anyway, and then executing that to answer these questions. Um, so there's 313 missing, one missing for this. Um, so we had quite a few rows with an outlier. The strongest outlier columns are balance, 10-year cash advance, PRC full payment. Um, and it's telling us it's not necessarily a bad thing because a lot of this data could be naturally skewed and have extreme values. Um, and one of the things we realized, anyways, about this data is we were using it for doing dimensionality reduction. So those outliers kind of get reduced naturally in the dimensionality reduction process. So even though this report is telling us, yeah, there's quite a few outliers here, what we were actually using this example for, it didn't really matter because we end up compressing it to a couple of features to do plotting and ultimately we did clustering with this. So just using that older data set. But of course, if we were doing something like a classification or something, then it might be a bigger deal. We might need to handle those outliers in some way. Okay. So then it says we can do some other things. So obviously we've done these in the past. So correlation heat maps, box plots, cleaning steps for modeling, exact rows with missing values. It even gives us a couple plots. So really nice tool here to do some data analysis. It can even do distribution like histogram plots. It can generate those. Very, very nice use of generative AI to kind of adapt the LLM capabilities to be able to essentially what's happening here is write the Python code that we would be doing anyway to do a lot of this analysis. The prompts we ask kind of dictate what code gets generated, which provides some type of maybe matplotlib plotting like this, or like a seaborne heat map, or the histogram plots, or these kind of missing values, or duplicates, or outliers, and such. Okay. So that's just an example of working with this tool. And of course, we could ask more and more prompts. We could, try to look at some of these suggestions. But it's really easy to get started with. All we had to do was upload a data set, start asking some questions about it, and we see that it can, pretty easily do that analysis. So pretty cool. Um, awesome. Any questions about that? And one thing I'll say again is we are going to spend some time reviewing how to do these things manually. So I know we're using AI right here to ask to do that. But it's still, beneficial for us to know how to do that by hand and have a good intuition on how to do that and kind of what it means, right? When we say, okay, no missing values, or why do we need to even look for missing values? We have a good intuition that, well, we need to do that if we're going to do any kind of modeling with it, whether that's, supervised or unsupervised. Okay. So that was the Julius example. Um, and again, encourage you, you could try adding some more questions. You could try a different data set too. upload that. I just chose this one, but really we could work with anyone that we've worked with in the past and ask these similar kind of questions. Um, okay, so let me go to our next example. So we just did that demo. So we can do data analytics, and I should also say, like, a lot of these tools these days have, the generative AI plugged into it. So like Tableau, if you've ever worked with that, has like kind of like a built-in chat feature, and you can ask questions and that and things like that. So that's pretty common these days. Um, I wanted to talk about this last use case here. So we've looked at a lot of different tools. One of the ones we're going to look at next is Otter, which is going to help us with speech to text. So essentially, transcribing audio and speech in particular. This is a capability that is becoming very, very popular into most like note-taking applications like a Notion, or even Zoom itself has this. We use this ourselves, right? For recording these sessions, we have the transcript that's automatically generated. Um, but there's lots of tools that can do this where they basically hook up to meetings or video conferencing, and they can basically transcribe the call audio. And so we're going to take a look at an example of that, which is Otter AI, if you've never worked with it. So the example we're going to do is essentially working with some sample audio data, which I was able to grab off of Kaggle, which is I think we've talked about it before in the past. That's a website for a lot of data science and data science competitions. They have audio data there that you can run transcription software over, like Otter, and try to transcribe it. So we'll do that. Uh, let's go over to that demo, which is demo 16, if you have this one. So we just did demo 15. This is demo 16, which is transcribing audio calls to text. And we are going to basically just go into Otter AI, create a free account, and then use it to generate a transcript of an example audio file. So go to otter.ai. So we'll go over there. So that's where we are, and we'll click on start for free, which is in the top right corner. And just log in with one of whatever way you want to log in. You can create one. You can use your Google. I'll just use Google here. So just connect it to if you wanted to transcribe like certain meetings automatically, you can connect it that way. Um, skip over that. So you have to go through this. Let's skip all that. Continue. So just continue all the way through. And let's just assume that we are doing, okay. All right, so we finally get to this page, and essentially what we want to do is upload a particular audio file, which I'll share with you guys. This file from the demo document, by the way, doesn't exist. It's old, from an old drive link. So I'll share with you in the chat if you want to run it yourself, the file that we're going to use. But essentially, we'll click on Browse Files to upload an MP3. In this case, it's actually going to be a WAV file. So we will, or in this case, it's actually import. It used to be browse, but now it is import. So let me share in the chat. I have a audio file, which is just a short clip of some just sentences. They're very random sentences, but it's again, I got this from Kaggle. Um, if you want to try this one. So what we can do is try importing this and then click on browse files and then the harvard.wav. You can see it's uploaded there. And then it automatically will go through the transcribing. It's only an 18-second clip, so there's not going to be a lot of text. I think it's like 4 to 5 sentences. But just to see the capability, we can go to the transcript. So it says the stale smell of old beer lingers, takes heat to bring out the odor, cold dip restores health and zest, salt pickle tastes fine with ham, tacos al pastor are my favorite. Is zestful food is a hot cross bun. So just random sentences that are kind of generated here, but um, this is transcribed directly from that audio. So pretty cool usage of AI there to break down that audio and kind of map it to this text, right? Is ultimately what that model is doing underneath the hood. Um, and it can even summarize that for you. If in terms of like meetings, et cetera, there may be like action items that could be summarized from directly from the audio transcript. In this case, nothing really comes out of this, just random sentences, but um, you know, we can even ask about the conversation on the right. So that's a cool feature of Otter is we can ask for a summary. We can start prompting with this conversation, right? Because essentially what we did we transcribe the audio, and then this generates some text, which could be used as context to ask some follow-up questions about, right? So like we could ask what were the main topics here that are mentioned? What were the uh, key action items? Were there any deadlines mentioned? We could ask a lot of questions about our text, and you can imagine like this could be very long. If it was a very long meeting, there could be a lot of text, and we can kind of ask questions about it here, just like we would with kind of a ChatGPT or something. So, that may be uh, useful. So you can, yeah, so you can integrate it with Zoom. I think it's over here in the integrations. So you can add integrations with like different sources like Zoom or Salesforce, Slack, Google. So like if you have a G Meet or like a Google Calendar meetings, it can hook up to that. So yeah, I think you just go over here to integrations. I think you can set it up through this page. This is the free one. You can trial the Pro for 14 days. Yeah. So when you go through this demo, you have the option to initiate the free trial for the 14 days of the Pro version. Um, with the basic version, you only get a limited amount, obviously. I think you can only upload like 3 files. Otherwise, you only get 300 minutes of transcription, 300 minutes of audio to transcribe in a month. Um, I think it resets every month with the free version, but yeah, you can utilize different plans here. Um, but with free, you can still integrate it into Zoom, Teams, Google Meet, and you get 300, yeah, per month. So that's what it was, per month minutes. Yeah, it will transcribe everything and you get the summary. Exactly. So, when we just did this one, we uploaded this and got a transcript. But yes, it will basically record all the audio and then generate a transcript for you, and then you can it will also summarize it here. Um, and then you can ask questions about it too. So you can kind of prompt just like any other, AI model. You can kind of prompt about it. Um, it'll give you an outline too, I think. So if obviously if you have a longer, this is just a few sentences, so it's not going to mean very much, but like if you have a very lengthy recording, it will give you kind of an outline of the discussion here. But you can, like I said, you can follow up with questions related to this transcript. So that's pretty cool too. And kind of chat with it. But you would get all that kind of here, like your different meetings would show up here. You can record them and then essentially have a summary and a transcript, which is very nice. So that's a really cool tool. But again, it's just one tool. There's a lot of tools out there that can kind of do this. As I said, Zoom kind of has its own built-in one. We actually use it when we post the recordings. It comes with a transcript, which is like Zoom's internal transcriber system that transcribes the audio from the Zoom meeting and puts it into text. And you usually can see that along with the uh, recording. So that's helpful. Okay. So just some of the takeaways here from the uh can Zoom meeting owner block Otter? I believe so, yeah. I think it can turn it off and not allow it, potentially. Yes. Yeah, I think they can. And generally, that's like a good practice to ask permission, anyways, if you're going to do that, because it does record it. Um, so you get all the audio playback along with the transcription. Generally, it's a good practice to ask for permission if you're going to do that. So, just or give people a heads up that, hey, this is being recorded and transcribed by my AI note taker app, just so people are aware that, things are kind of being recorded. Generally good practice. Okay, so what we looked at in this lesson is looking at some different ways that Gen AI can automate things and do different tasks for us, especially with language, right? We looked at a bunch of early on in this lesson from last week. We looked at different language applications like sentiment analysis, translation, and then extending that into doing things like profile creation on LinkedIn and kind of automating a lot of those tasks, which was nice. We even saw the versatility in some of these models to be able to work with different kinds of data. We just saw like we can work with audio. Um, we can work with images from an input and output perspective. Like we can generate images as well as we can use images as input, which is nice for a lot of applications. And then what we saw are some custom models even. So we looked at a bunch of different GPTs themselves, which are those community created models that are fine-tuned on particular tasks. So we looked at, different ones for writing, tutoring, research, programming, which are nice. And then we looked at a bunch of basically software integrations with Gen AI to do like automated workflows, like with Zapier, or build out roadmaps or do transcription. So, or data analytics, all kinds of different things. So really cool technology and it's growing every day, it seems like, right? There's so many new tools out there. Seems like day-to-day basis, there's new ones. So um, rapidly evolving. And we also looked at along the way, in this course was the Hugging Face open source landscape, right? Which I think was really cool to get a feel for the fact that there's all these models out there that are open source and There's also a lot of cool tools that are being hosted there in the Hugging Face spaces that we can kind of play around with. If anything, they're cool, but they also give kind of inspiration on what the capabilities of generative AI are, which are pretty cool. Okay, awesome. So that being said, let me jump over to some uh, some of the notes about the project that's at the end of this course if you want to give it a try. Um, Let me pull that one up. So this is just the project problem statement. If you have that available and want to look through it, this is for this generative AI literacy course. It's a very simple project. I recommend giving it a try. It was just ChatGPT driven. The situation is that we want to create a storytelling adventure using ChatGPT. Um, Basically, write out a unique and custom story completely using AI. Um, and so essentially, as you go through these steps, you're going to be um, building out a story, like a short story, by picking out all the various elements and then letting generative AI kind of drive that story building and generation of that text. So essentially, what you need to do is define a theme, so or essentially a genre for the story. So pick your favorite. It could be, it doesn't even have to be one of something on this list, but this is a good starting point. Something like fantasy, science fiction, mystery, adventure, action, whatever it is, your favorite genre for stories, or like a book. So you want to start there with a theme in mind. And then you want to ask, now again, all of this you want to go through ChatGPT to do. So you want to use it to your advantage here to build out characters. That's the next place you want to go. So if you have a theme in mind, with that theme as context, you want to build out characters. So create some characters, including um, their names, personalities, and backgrounds, and maybe some information about them. So you have a theme in mind first, and then you can kind of create some characters with it. And then, given the theme and the characters, then you start to build a story around it. So you ask to build a starting point for your story to kickstart it. And then you basically go through a series of prompts to build on the initial story. So describe the actions of the characters, provide narrative responses, expand the story, and advance the plot based on your own ideas. So you're building out your own story, but you're using generative AI to kind of help you do that creation. Um, so again, this is all going to be driven by uh, the AI and your own kind of imagination. Um, Ultimately, what you want to produce for this project is just the final story, and then you want to upload that as kind of your project submission. Um, and so very easy, lightweight, really no code that you're doing, really no it's mostly all just prompting that you're doing to build out the story. And um, yeah, so you can essentially what you can do is just print out your you can print out to a document like a PDF your entire prompt page that builds your story. That will work too as your upload. Like as your project upload. So like as your so imagine like you have all your prompt, you're going back and forth, essentially just print all these pages, but instead of physically printing them, just save them to a file like a PDF. Um, that should be good. Or you can screenshot it and put it in a Word doc or a Google Doc. However you want to do that. But that's the main idea for this project is really using prompting to guide just storytelling. There will be yeah, there should be multiple prompts for sure. There should be one for building your characters, there should be one for the initial plot. There should be and then multiple ones to continue the plot beyond that. So there should be several prompts, yeah, for sure. This is the Gen AI literacy course that we're currently doing. So this is for the generative AI literacy course. This is a project for that. Yeah. Very simple. Very simple, just prompting, practice and building out a story. So it's meant to be a little bit of fun too. Um, nothing too fancy. Okay. Very good. So very simple. Any other questions about it? Again, I think the best thing to do is just print out your so if you're in ChatGPT and you have so I go to one of the previous ones we did, like our eco-friendly water bottle or customer feedback, whatever one we've done in the past. Um, just printing out this page. So printing and then basically saving that to a PDF, which should have all of the prompt with it. So this has all of our content and our prompts inside of it as kind of a printed out page. That should be good. That PDF file should be good. Okay. Cool. So, with that being said, that kind of wraps up the generative AI literacy. So we covered all the material there. Um, you know, what I would say is there's a lot of material we obviously didn't cover that's expands generative AI, but luckily, if you're interested in generative AI, we do have additional programs that specifically deal with generative AI and Simplilearn. And so if you're uh, and I've taught those before. Those are really great programs that go into detail on things like agents and multi-agent systems and MCP and all those really fun like generative AI topics. If you're really interested in that, recommend looking into that program too. The uh, um, it's usually called AGS, Advanced Generative AI Systems. Um, so if you're really into that, you could look into that program. That's a fun one. Um, do you recommend using a specialized? You could try if you want to use GPT. I would use the Write for Me. So one of the writing GPTs. So if you go to the GPTs list, which if you remember how to get to that, is just going to more apps, right? More apps, and then in the top right, GPTs. I would go to this writing category and use one of the top writing ones. You could even like the one we used in our demo is called Write for Me. So you could use that one. So write for me. So this would be a good one for narrative writing. This is a really good one for writing. I would recommend trying. Yeah, so like you could just use the standard one. You don't have to use this, but this would be a good one to try out for building the story for sure. Write for me. Are we going to build agents? No, we won't be building any agents. Building agents would be more in the realm of the advanced generative AI courses. It's not really in our scope. If you're really in, if you're curious about building your own agents, though, I could point you to a few things. So something you may want to look into are Python packages like LangChain. LangChain, CrewAI, and AutoGen. Um, these are also in 8N. These are packages. Yeah, so these are all Python packages that are free, that I think are worth exploring if you want to build your own agents. These are good examples to kind of explore. I think, yeah, so I think the Build AI agents, I think I'll have to double check on that. I think that's an elective course. I'm not sure it's part of our core curriculum. I'd have to double check that. I might be wrong, but I thought it was, I think it's an elective. So we might do it. But I have to double check. Any recommendations for agents which is self-learn? I would say just look on YouTube for building agents. I don't have like a particular one in mind, but that's I've looked on YouTube before and kind of found some good videos there. Um, Generally, I can't remember the name of the people who did it, but um, yeah, I found them on YouTube and they were pretty decent. But those are the packages I know that are very widely used in building agents that I think are worth exploring if you're interested in building them in Python. Okay. How many more classes? So I know we have our final capstone. So that's at least one, and then potentially couple electives. So at least one, maybe a couple electives, but not too many left. Yeah, the Azure, I'm still working on seeing about that. Yeah, I'm still working on the Azure part. From what I had learned, we that one is designed to be taught by a Microsoft certified instructor, for like from Microsoft directly. So we have to coordinate that, which so I'm still in the works of finding out about that. So we'll definitely update you when I find out when we're going to be running that on the Azure particularly. No, so we didn't do Azure AI together. We just went past it and immediately jumped into the Gen AI literacy. But we still like the next one for us together is going to be our capstone course, which is mainly just meant for review and going over the capstone projects that kind of are just our final capstones for the program. So we have that to look forward to. Um, if we could do one class on building agents. Yeah, we could yeah, maybe we'll have some time on Wednesday, maybe Wednesday and Monday. If that's a topic you guys are really interested in, I can certainly cover it. If we want to do some examples of that. We did. We skipped it because the design, so for the program, um we need a someone from Microsoft to essentially teach that, which we have to coordinate with them to instruct it. That's why the materials weren't available. They provide them. So I'm working on getting that set up for us, which we'll announce, of course. So more to come on Azure, but that has to come from a Microsoft certified instructor. So yeah, more to come on that. We did skip over it for the moment, and we just jumped to generative AI literacy, which is what we've been doing lately. Um, Again, what we have next on the immediate horizon is our capstone. So that's actually what I wanted to pivot to next. And then, so I think what we'll do for the immediate plan is we'll go to do some capstone review. So I want to spend the rest of today doing some review of some notebooks and examples that we haven't taken a look at in a while that I think are worth reviewing from a program perspective, especially really older things that we just haven't worked on in a long time. Um, so I wanted to spend some time reviewing that, and then it sounds like you guys want to learn a little bit more about agents, so we can spend time doing that, likely on Wednesday, um, overviewing some agent stuff, and then reviewing the projects themselves, like the capstones, agents and Claude. Definitely agents. We could talk about LLMs, um, like Claude, I suppose. But yeah, we can definitely cover agents. That's fine. All right. So what I wanted to do is pivot a little bit to um, a little bit of review of some older material. So what we're going to do is bounce around a little bit into some of our older notebooks. So if you do want to follow along, we are going to be going through some older notebooks. Again, and the main purpose of it is to just walk through some material that I think is going to be beneficial to review, looking ahead to the capstones in particular. But also just general program review. Like we haven't covered these things in a while. I think they're worth going back over to clear up any rust that we might have on it, see some examples again. So we're going to be going through some old notebooks from a few of our courses. So our data science course, our machine learning course, and our deep learning course. I intend on reviewing some notebooks from those just to walk through some examples and get that review. So that'll be the next thing we do. I read that you can build automation with Claude. Yes, yeah. So Claude has a few different tools out there to do different automations. So it has uh, Claude Code, Claude Cowork, um, which are kind of geared at different audiences for building out different things. So like building out software. Cloud Code is kind of the terminal CLI that they have to do that. And then for doing like day-to-day things on your computer, um, Cloud Cowork is a very popular tool for that. That one's geared more towards like product managers or like uh, other kind, not necessarily. It's like non-software developers is kind of what it's geared towards, um, but yeah, they have several tools to do automations for sure. Yeah, so Claude Cowork is a good tool. Yeah, Claude Cowork is pretty popular for a lot of product managers. Okay. So what I wanted to do is go all the way back to I have an old notebook here, which is our all the way back in our data science course. So this is our lesson 9, 9.01 from our data science course. So if you want to follow along, you're going to have to go all the way back to those materials from our applied data science course. And I wanted to go into lesson 9 and just review some data wrangling and working with data examples because it's been a little bit of time since we've really had to exercise our Panda skills. You know, when we worked in uh, neural networks, we were working a lot with, especially towards the end, we were working a lot with images and text, which weren't necessarily inside of data frames, especially images, right? They're definitely not. Um, so it's been a while since we've had to work directly with data frames. I just wanted to go back and kind of review some of these concepts for us because I think they're really important and I don't want us to forget them. And they will be useful for looking ahead to the Capstone projects. Okay. So again, this is lesson 9 from our applied data science course. We're going to be bouncing around a little bit from that course to the machine learning course to the deep learning. So we'll be hitting a lot of review topics here, is kind of the plan. I want to start here and just go through this notebook a little bit just to remind ourselves of what data wrangling really is, which is a fancy word for just essentially pre-processing or prep, right? Essentially, what we're doing here is preparing our data for some type of use case. And remember back then, I used to say it's really for two cases, usually for building a model off of, which is what we've been interested in, or telling a story, right? Cleaning it up so we can tell some type of story. But from that prep or processing, there's a lot of things we can do, right? We can check for duplicates, we can remove and check missing values, we can handle missing values in certain ways. We can do transformations like doing feature engineering. So there's a lot that we can do with our data. I just wanted to remind us of that and kind of look at some examples to jog our memory there. Um, so going to discuss that. Now, a lot of it starts from this simple command of loading our data from a CSV. Um, so that's what we practice with. Now, in reality, do you always load from a CSV? No. A lot of times you are querying a database or something like that, and you may not be reading directly from a static file. But in any case, you're usually pulling your data back into a data frame, even if you're running a query. A lot of Python code is packages exist to query a database and pull all that resulting data into a data frame. So in whether it's from a static file or from a database, it ends up in a data frame. It just so happens it's easier for us to, work with it from a static file perspective because we can share that file and work with that pretty easily. Um, so this is where it all started for us, was reading in data that usually was in a CSV, and that produced our data frame. Once we had our data frame, we know there's a lot of things we can do to initially inspect it. Um, and so these were our basics of inspection that I don't want us to forget, right? So we have dot head, dot tail, which allow us to look at the very top of the data frame or the very bottom of the data frame, which is the last 5 rows, first 5 rows, last 5 rows. Um, so these were really important, and these are functions that especially we find ourselves running right after loading. Usually the very first thing we do mainly as a sanity check, right? Did we just load what we thought we loaded? And also we get a quick view of what's there. Did we load the right data? Um, is it actually parsing things correctly when it loads the CSV? Um, so that was a good sanity check and something to get in the habit of when you're loading a data frame, right? Is just immediately df.head, take a look at what we have from a basic perspective, as kind of one quick check. Um, in Prod, how do you manage daily inference data? So, uh, the typical way is you have some data engineering pipeline that would run every day on a schedule. So, and there's a lot of orchestration frameworks to do that. Very common is like Airflow, for example, or dbt Cloud or something. One of these tools will run a data engineering pipeline, which would scrape your data or pull it in from wherever or ingest it from some source, maybe do some basic cleaning and transformations during that process or aggregations, whatever the case is. and then write it to some database or yeah, typically to some database, which could be um, like a relational database, typically, and you know, you run that on a daily schedule, and then you then can predict against that data in a batch. So you can run like once you've dumped all that data somewhere, you can run a model against it, right? Because you can query it, you can execute your model against it and generate a bunch of predictions. And that's usually, if it's daily, it might be like once a day, right? That you're doing that. But like, how do you manage it? It's usually through a data engineering pipeline um, that's running on a schedule, but it's generally orchestrated using some uh, tool like Airflow. It's pretty common. So you usually manage it through a pipeline. And again, that pipeline is going to be constructed to do different things, like initially query it from somewhere or scrape it from somewhere or aggregate it from somewhere and then process whatever transformation and then write it to, it's usually a job that's then going to write it to some production database that you would then read from in your inference job. Does that make sense? It's usually the flow. But that's more of a data engineering topic. But yeah, that's pretty common. Okay. Now, just to remind ourselves, we had head, we just talked about tail, we just talked about one other that a couple others I actually wanted to mention, and then we could take a break is the info. So we can't forget info, which is a really nice way of initially seeing what columns we have and their data types, right? So info is this view here that shows us what columns we have and what their types are. The other view we get from info is we can kind of deduce if we have any nulls, right? Because this is the number of rows that we have, and this tells us how many of those are not null from within each column. So generally, it's a good sign if this number matches this number, meaning every entry in that column is not null, which is good, right? We don't have any missing data in that view. So info can be helpful, mainly to lay out what columns we have and what types they are. And remember, when we see object, that's generally a string. So that's and which is pretty typical for like a categorical variable. Dates are also generally read in as strings until we convert it, which we'll review how to do that, which is generally a good idea. You want to convert your dates over to datetime objects. Remember, that's helpful to do. But we have numerical types like float and int, and we have strings like these. And of course, if we're building a model, we don't like strings. We generally try to convert those to integers through the one-hot encoding process. So we'll remind ourselves of that too. We have info. Don't want to forget about that as kind of a nice summary of a summary operation that we can run. The other summary that we can run is describe, right? This actually gives us a statistical summary of our data frame, which can be useful to see basic stats like our mean of every column, our min and our max and our percentiles, standard deviation, those things. So that can be useful to see, which kind of looks like this. So we get this for every numerical column, right? It's only going to be processed on the numerical columns. All the columns that are strings, remember, we don't get any stats on because it doesn't make sense to compute like an average or a standard deviation, right? So only the numerical columns do we get these stats, but we get, a mean, a min, and a max, which can be interesting to see. So like we can see what the min and max prices are, bedrooms, bathrooms, all these features, right? We can see their various statistics, which is an interesting view. Okay. All right. Any questions about the, I know this is really old, but I think it's worth reviewing. Any questions about these functions? Hopefully it jogs our memory a little bit. We have head, tail, info, describe, very, very basic on a data frame. Really helpful functions to get some quick information about the data that's in the data frame, right? So the head, tail, info, describe, really useful. Also, the shape attribute is, useful if you want a quick view of how many rows and columns you have. The shape is just the dimensions, right? The rows and columns uh, that we have in our data frame. We will um, continue and take a look at how we access different rows and columns. This is just a quick reminder on loc and iloc. So if you guys remember, we had this function here on the data frame to help us access different rows and columns. Um, and they're based on different indices. So the iloc is the I is short for index, and really the index is with respect to the natural kind of row and column indices of each row and column. So these are going to be numerical positional indexes. So not like the index we have that it represents like the name of every column, which is what loc would use. So iloc is just purely the position. So, like an example would be this, where we want to access all rows, but only the first 10 columns. So, this in terms of iloc, we have a kind of coordinate here, which has a colon representing all. So, meaning we have no starting and stopping point on our slice. So, that's all rows, but this slices out to the first 10 columns, which would not include index 10, right? It goes basically zero, which is if we don't remember for slices, if we don't have anything there, that means we start at zero. Um, and go up to 10, but not including 10. So it's gonna be 0 through 9. And these are positions, right? So this is whatever is the first column in our data frame, all the way up to column 2, 3, 4, on and on up to column 9, regardless of their name. Just whatever happens to be first, left to right, is what iloc will pick up with this index. So iloc is useful if you know the positions and you want to grab like the first 3 to 5 columns or 10 columns or whatever. Another common use case, we've actually seen this before, is like if we know our label is the last column, we can do something like this, which is basically saying I want to grab all rows and all columns up to the last one, which is this would be useful for a situation where the last one is special. Usually it's the label, right? If the label just happens to be that last column, this would be perfectly fine to grab all of our features, right? All of the features, which is basically the entire data frame, but that last column. That this iloc would be perfect for that. Uh, so that's when you would use iloc, is really you're grabbing things based on their position. But a more typical use case for us is going to be using something like loc, which would grab things based on their index in terms of their assigned named index. So not their positional index, but their actual data frame index, which for a row could be just, and typically is just that it happens to also be the positional index for the row, but for the column, they have names, they have labels to them. So this is where with loc we can actually utilize names within there to grab maybe the first however many rows and whatever particular columns we want to grab, which could be a list of columns. It could be a single string to represent a single column. It just depends. But so that's the main difference. If you ever run across code and you see loc or iLoc, remember, those are just accessing rows and columns, and we have these various ways of doing it, which are slicing with these indices and then using the name of the columns. Remember, we can also like if we want the entire column, we also can bypass using loc and do something like this where we had result is df, and then we can just pass in a list of columns. So we could pass in bedrooms, and we could pass in bathrooms, and we could pass in um, oops, we could pass in price, whatever particular columns we want to access, and on and on. And those could be inside of this list. The difference with this is this will grab all rows belonging to these columns, right? So we don't need loc if we're just going to grab all rows. So this kind of bypasses this part of it. It would actually be directly equivalent to if we just did this and just said, I want to grab all rows, but just those columns. It'd be the exact equivalent, but it's kind of redundant. We don't need to do that. So remember, if you just want to access particular columns, you can do it this way. Um, if you want to access particular rows and columns, you usually want to use something like loc, or iLoc if you just want to use the positions. So just reminding us of that. Um, One thing I also want to remind us of is how to filter a data frame, which I think is really important and something that um, is basically something that we haven't practiced in a long time, but I think is worth reviewing. If you guys remember, the way we filter a data frame is we essentially use a syntax that is like this here on this line. So this is our way of filtering a data frame, which is to say, I want to access particular rows of this data frame that meet this condition. So what we do is we do df and then bracket, and then I put some type of condition inside of that bracket, which could be formatted differently depending on the condition. So this is a pretty typical case where I want to filter this data frame to be only the rows where the bedrooms are greater than 4.5 and the bathrooms are greater than 3.5. So I'm actually combining two conditions. Do I need to do that? No, I could just use a single condition. So let me show you that. Like if we only had a single condition, it could be like that. So this would filter the data frame to only the rows where the bedrooms are greater than 4.5. Um, but notice it's still this syntax. It's df with a bracket, and then we have this condition. The condition is how we would read this is I'm checking the bedrooms column to see which entries are greater than 4.5. Right? That's what this is really doing is accessing this bedrooms column and seeing which entries of this are bigger than 4.5. Now, if we have another condition, we do the logical and, which is this operator in Python that's doing the and between these two conditions and basically checking if this basically wherever this condition is true and this condition is true. So only in the situations where they're both true, I would filter out to those rows, right? And so that's how we do a filter, right? We have df bracket and then we have some condition in there, which could be a very lengthy condition. This is kind of a lengthy condition, which is checking multiple conditions better. So we need the bedrooms to be that column to be bigger than 4.5 and the bathrooms to be greater than 3.5. We could assign the DF a name here. Yeah, that's a great point. That's probably something we would want to do. So we could call that filtered or something. Yeah, I think that makes total sense. So this is going to give us the filtered out rows of that original data frame, which we could reference further on in our code and manipulate and do whatever with that we need to, right? Um, yeah, that's a great point. Absolutely. That's pretty good practice is to store that result in a new data frame. So we have that going forward. Yes, that makes sense to me. And of course, you can call it whatever you want. I just happen to call it filtered. But yeah, good point. Here's another type of filter, by the way. If you have a string, a column that's a string, you can access the string attribute and do a filter such as starts with or ends with York or whatever substring you want to put in there, which would examine all the rows here of this of the city column where it actually the string of the city ends with York. Um, and so that would do that filter. But again, look at the syntax of the filter. It still follows the same convention, right? It's still a DF with a bracket. It's just inside of the bracket, the filter condition. Um, the filter looks a little different. Is it better to filter on a string before transforming string to integer? Yes, I would do that. Yes. I would filter it before and then do the conversion because then your conversion is going to operate on much fewer rows potentially. So yes, I would do the filtering. And the reason I would do that too is because the filtering is more natural here. Um, not to say like I don't think it's wrong to do it the other way. You can certainly do it the other way. So what would that look like if we did it the other way? If we did it the other way, we would, so one hot encoding would give us columns like it would give us a bunch of columns on the city, which could be a very large data frame. That's the risk with doing the one hot encoding first, is we have a lot of cities. And so some of them could be like city New York, which could have a one in it, um, for the cities that are actually where the city string is actually New York or whatever that is, etc. And so there could be a lot, right? There could be that's the risk with one hot encoding first is we could end up with a lot of columns. Versus if we just do the filter on the string, we end up with only those columns, and then we could then we could easily encode it. Hopefully that makes sense. Like the one hot encoding could lead to a lot of unique. This string could be very unique in all those entries, and so we end up with a lot of one hot encoded columns. Okay, very good. So the next discussion I want to have is about missing values, classic discussion that we've had before, but just wanted to remind us about it is first of all, how to find if we have any missing values. Um, and so the proper way to do it is a check like this, where we do the is null and the sum, which remember will tally up how many we have missing per column. So we get a result that looks like this, which has an entry for every single column, and it has a total for how many we have missing. And ideally, we have zeros across the board there, which would be the fact that we have no missing data. That's great. Right, so that's the ideal case is that we have no missing values. Um, but of course, that's not always going to be the situation, and so it becomes a kind of a choice. We've talked about this is what do we do in the case that we do have missing values, which does happen from time to time, and we do have to deal with it because models are not going to like those NANs. We have seen that before, right? With all the various models that we've studied, they're not going to play nice with an NAN generally. So we need to deal with it in some way. And so we've talked about various ways of handling that. Um, One way is to just replace the null with a particular default value. So that's one route to go, which generally is going to involve using this fill in a function. So whether that's on a particular column or the entire data frame, um, we have some way of uh, utilizing a function to fill in any value that we have. Um, Now, do we always want to do that? Maybe not. Like if we have remember, if we have a significant number of nulls, we generally just want to drop that column. That would be the better strategy because if we're filling in a bunch of missing data, it's almost like what good is that column? It's kind of all fake data in a sense. Um, so if the missing data is a significant portion, and I think a good rule of thumb is like greater than 20%, usually, then that's a good candidate to just drop that column. It's got too many missing values. We're going to end up filling it in with the mean, which is going to skew um, the data essentially to be very concentrated on the mean because most of the values are going to become near the mean anyway when we fill in that blank. So if we have a significant portion of it, just consider dropping it. We could consider filling it in if we have very little. We could also consider dropping the rows if we have very little because, especially if we have quite a bit of data, it's not going to hurt us to just drop a row and get rid of those nulls. So if it's a very, very, very low percentage, we could fill in the blank. We could also just drop it. Drop the row that contains that null. That's another strategy we've used before, but we do have to make a decision. So that's the biggest thing is identifying them and then doing something about it. There's not generally a right or wrong there in terms of filling it in or just dropping it. Um, but you do want to be aware of making that decision and at least handling it in some way. What you should not have are nulls going forward into the modeling phase, right? We want to handle those one way or the other, whether we've dropped them or filled them in. So just reminding us of that. And of course, the other function we could use is df.drop NA, which would drop nulls. And of course, we can do that in place to permanently drop those nulls, which is going to drop all the rows that contain at least one null value. So got to be careful with that because again, if we have a significant amount, that's going to drop a lot of rows, um, and we may not want to do that, but we may, that's fine to use if we have a very low amount and we have a good amount of data. We can spare some rows. Okay. Thought I would remind us of that. The key takeaway is remembering that we can always check for them, which we should do, and deal with if we have them, deal with them in some way. Fill it in with an appropriate value like the mean or the median or the mode in the case of a string. Um, and then or drop if there's very few of them, or drop the column if there's a lot. So a significant portion, we can drop the column. Okay. So reminding us on that, any questions on missing values? That's a big one. Got to deal with that. By the way, I will show us the code that does this in the scikit-learn pipeline. So remember, we can do a lot of this on the data frame. We can also handle this inside of the scikit-learn pipeline when we build a model, right? So we actually saw that we can kind of chain together a lot of these processing steps like scaling, imputation, which is what this is called, by the way. Remember, there's a fancy name for filling in missing values, which is called imputation. That's what we're doing here. Or I should say that's what we're doing here. Scikit-learn has some helpers to do that in the pipeline. So we can take a look. We can look at those examples coming up later too. of the scikit-learn pipelines. Okay. Okay, another thing we can do is remove duplicates. So this is where we have exact copies of rows, like literal exact copies of rows. And that's good to do just because uh the duplication is not going to help us in any way. In fact, it'll hurt us to have lots of copies of a single row or even multiple copies of a single row. From a modeling perspective, that's not very good. Because it introduces a, dependency to some degree or correlation amongst those data points. So we don't want to have those. And so it's simply we can check for duplicate rows and drop them as a simple processing step. It's very rare that we would have this, especially, this is something that likely would get filtered out upstream in like a data engineering process. So it'd be very rare we would actually get any duplicate rows, um, but doesn't mean we can't check for it. Um, Pretty easy to just drop those. So that's the function to do that. Okay. So that brings us to dealing with dates, which I wanted to remind us about too, because I think it's helpful. And we've seen this a couple times before. We'll see it here again. We haven't dealt with it in a while. And that is converting over string date columns into the datetime object columns, which are very, very beneficial to do because in the datetime object, we can manipulate it very nicely as an object rather than just a string. So, very simple code to do that. Remember, all we have to do is run the pandas function, the pd.toDatetime, which will convert date strings. So we just pass in our column of dates, and it will convert that into datetime objects. And the typical syntax we do is to just overwrite that date column. So we just rewrite it. So this will set our date column equal to the conversion result of operating on the original string date column. And so by the time we run this, uh, we get these dates converted over to a datetime object. Um, and of course, the type of that will change as well. So if we were to run like df info on this, this date column would now be a datetime object type rather than a string or just a regular object, which would be a string, right? And so really, really simple code, but this actually helps us a lot because when we have this datetime object, we can do a lot of things with it in the feature engineering realm, right? We can extract day of the week. We can figure out if that date's a weekend. We can figure out what week of the year it is, what month of the year it is. We can extract all that date related information out of that object as long as it's in a datetime object. It's really easy to do, right? So that's the whole point is to convert it over and then it becomes useful to us. Now, do we need to do that? Like maybe not if we don't intend on working with the data at all. Like for some reason, we're doing classification or some type of regression, and we don't actually care what the data is, which we may not. Like that may not. The date's generally not going to be a useful feature. Um, so we may just want to drop the date column ultimately. That's fine too. But it can help us with engineering new features that may actually be relevant. Like was this a weekend when we made this sale? Or was it a weekday? Or was it what season was it? What month of the year was it? Like those may be useful features for a model and we can derive those from the date object. Um, and then we can always drop the date itself if we don't need to use it, right? Okay. So this converts that over. And remember, this is the example of uh, this is the example of swapping, like this is the example of extracting day of the week. So once we've converted it over, we can access the different date attributes by looking at the DT attribute of that datetime object. So the DT and then dot day of the week. So this accesses just like we can use str to access the string attributes of a string column. Now that it's a datetime object, we can look at day of the week, the day of the week, which is um, telling us, is it it's an integer which represents like Monday, Tuesday, Wednesday, etc. Does two datetime allow for formatting? It does, yeah, it does. I'm pretty sure. So when you run this to datetime, I think it has options to convert. Um, so if we were to look at this, yes, I think it has a format. So it has different format. It has different units. It has yes, so it has different formatting options available in the arguments to uh, examine exactly what you want that to look like. So, yeah, that's so the default is to just map the date into um, the just a basic datetime object that is not that is not anything fancy, but I think you can change that format within those arguments. But the default behavior is just to kind of map it one to one with like this is year, month, date. It will read this and just convert it over into your exactly the same format, year, month, date. Yeah. Okay. All right. And then remember when we were looking at this data, one of the things about it was that we looked at the value counts of various columns. And this is just interesting to see is that this country column had every single row was USA. Every single row is USA. So, from a feature perspective, in a modeling perspective, that's not very useful. Remember, we talked about this at the time. That's not very useful from a modeling perspective. In fact, that's a good candidate to just drop from modeling because it's not going to tell us anything. If every single row is the same value, that's not useful. It's not good information. It's just in fact, when we're building a model, that column is always the same value. So it has no bearing on the outcome because it's always fixed. It's always USA. So it doesn't matter what it is, it really has no relationship to the output because it's always fixed. So this is useful to see for a lot of categorical features. Um, you know, we could plot it for sure and see like the histogram, or I should say the bar plot, and see what the categories are. But just looking at the value counts, we can kind of see here that this column has all of its values as USA. It's not going to be useful. In fact, we could just drop it. So scenarios when we want to drop columns, this would be one of them. The others would be like things that are not going to be useful for modeling, like customer IDs. Those are not going to be useful for modeling. Dates, probably not useful for modeling either, like the raw date, even the date object. After, we may use it to derive features, that's fine. But once we've derived those features, we can usually drop the date because it's not going to be useful in the model itself. Um, and then features like this, where everything is the same value, those aren't going to be useful for modeling. So we can certainly drop that. So we should be on the lookout for those, right? We should be on the lookout for reducing our data dimensions if we can, um, naturally through dropping things that we don't need, right? df.in unique is less than or equal to 1. Yes. Oh, I see what you're saying, where there's only one unique value. Yes, of course. Yes. I was a little thrown off by columns to keep. We probably wouldn't want to keep those. There's only one value. So I would maybe name it a little bit differently, but yes, I think I see the idea. I see the idea. Yeah, no, that makes sense. So that yeah, that's a clever way of doing that's a clever way of essentially getting at this. So if you were to do that code, so df if you were to do df dot columns, which will filter the column's name, and then you do df dot in unique, um, which will tell us how many unique entries there are, and we do something like this, um, which will filter. So this will filter the columns to be to be the ones that uh, only have uh, one or fewer. If it has fewer, that probably means that there's no data. Um, but if it has, one, that means it's a situation like this where it only has one unique entry across the whole column. And that would be a good, so like these would be columns, probably want to name these columns to drop, something like that. But yeah, agree. That's a really clever way of doing it. Cool. All right. So that now if we look at the data frame after after we grabbed this day of the week, for instance, so this creates a day of the week feature. You can see what that feature looks like. It's an integer, right? That just extracts what day of the week this date was, um, which may or may not be a useful feature. It just depends on the problem. For this data set, I don't think it's really an important feature at all, because that's just the date that this was recorded, like the sale. That may not be a useful feature, really. Um, Probably what's more important for the price of the house is probably the bedrooms, bathrooms, square footage, of course. Like that makes sense. Those are probably really important features. Um, the date, probably not that important. Um, Maybe it is, like maybe there's some seasonality to it and like the year matters when it was sold. That could matter for sure. But I think most of this data is within the same kind of general time range, so I don't think it's that important of a feature, but so we could likely get away with dropping that. But this is what the day of the week feature looks like that we extracted from this. Right. And only works because we would have converted this date to a datetime object. Okay. Now I wanted to show us some transformations that we can do. And these are things that we are pretty accustomed to by this point, I think, is just doing operations on the column level. And just to remind us, there's multiple ways of doing that. So um, one way is to use the apply function. So remember, when you're operating on a column, you have multiple ways you can handle that. One is using the apply function, which will operate a function on every row of that column, right? So this is a function. Remember the syntax in Python. This defines a short little function that doesn't have a name. So it's not a named function like we would build with our typical like def logarithm. So we're bypassing that to build an inline kind of function here, which is known as a lambda function. And the keyword lambda signifies that this is going to be a lambda function that has a single argument x, and which is x represents the row entry because we're applying this to the column. This represents every row entry. We're going to take the logarithm of that row entry. That's what that means, right? So X maps to the logarithm of X, and that's applying the logarithm transformation to that entry in the price column. So that's one way to do it. Do we need to do it that way? No, and you may see this perfectly equivalent version of it, which is we could just do mp.log and then just pass in the whole column. So both of these work. There's nothing wrong with either one. So you can definitely apply, or you can just do the function on the entire column at once. Both of these will give you the exact same answer and both work. Um, which one you use generally depends on how complicated your transformation is. So this apply lends itself well to applying a more complex function than a simple logarithm. So if we had something here that we wanted to process, like maybe we wanted to process a more complex function here on this, apply is flexible in that way, right? Um, versus here, this is often limited to, just operating. Like generally, we don't build functions that operate on an entire series. This would make sense to if we had a function that operates on a single entry, like a single input, which is more typical for building functions. So either one works, and these would both be equivalent. It's just you're going to see apply used in combination with a more complex function, something like logarithm or square root or multiplying by two, or squaring something, dividing by 10. Generally, you can just operate on the column itself all at once. That would actually be simpler than using apply, in my opinion. So for very simple operations, you can just operate on the column. If you're doing something really, really complex, maybe it's more natural to build a function uh, to basically apply to every entry, and that makes more sense. So you can use the apply function. Either one gets you to the same place, which is transforming that column in some way. So we've seen, so like these are transformations we could do. The let me make a comment here. This is equivalent to the apply method. So these are equivalent. Um, Now, this is a really important transformation that we have done before, which is scaling. Now, we don't normally see it like this because we usually apply the scikit-learn helpers to do our scaling, because scikit-learn has really useful functions to do this. But this is the transformation that we would be doing with something like a min-max scaler, right? So we know we can grab that from scikit-learn and just use it, but here it is written out kind of manually, right? So we're subtracting off the min, dividing by the max minus min. That's the typical transformation of a min-max scaler. What we're doing is generating a new column, which is the result of this transformation. So subtracting from the price column the minimum of it and dividing by this constant, which is the max minus the min. That's a single value. This is subtracting off a single value from every single row entry of the price column, right? And so it's really transforming this price column via this subtraction and division by this quantity. It has the effect of shifting everything to be between 0 and 1. That's what a min-max scalar does. Um, right? It shifts everything to be between 0 and 1, by shifting everything by the minimum and then scaling it by max minus min. So doing that automatically moves your maximum value to 1 and then your minimum to 0. So it automatically scales everything to be in that range. Okay. So you guys remember that we did that a while back, but that's the manual way of doing it. I'm going to remind us of the scikit-learn way of doing it shortly. We'll see that example, but that is the kind of manual way. Typically wouldn't do it this way though, right? We would generally, and the reason we wouldn't do it this way is because this doesn't scale very well to, like, we would generally need to apply this transformation to every numerical column. We want to scale all of those prior to doing modeling. Um, and so we want a quick helper to do that, which is going to be what scikit-learn can do for us. Because otherwise we'd have to go in and we'd have to do this for every single column, right? We'd have to go to the next column, like normalized bedrooms, and then do the exact same thing, which is um, writing out all of this. It's just that gets tedious for every single column, right? That gets tedious to do. So that's where we would bring in like the standard scaler or the min-max scaler from sklearn and just apply it to the whole data frame. Okay. But you can see like the normalized price ends up between 0 and 1 for all these. These are all fractions now. Obviously, the logarithm brings it down quite a bit from where it was, which is in the thousands. So these are in the uh, um, are actually hundreds of thousands or even millions in some cases. And then this brings it down into the teens, and then this brings it down even further to be between 0 and 1, which is generally where we want to be when we normalize things. For modeling, right, we want everything to be kind of in the same kind of ranges. Okay, any questions on this? We're gonna see, the scikit-learn way of doing it, but thought I would remind us on these kind of transformations we can do to columns in particular. Okay, binning. We don't use this one too often, so I probably will skip over this one, but it's a simple function it's the pd.cut, which will take a column and bucket the values into these various labels. The reason we don't do this too often is because, we uh, don't typically do this. We generally just leave the values as they are and model off of the raw price values. Like we wouldn't bucket them. Um, but that may be something we want to do. I'll tell you one application of that is like if we wanted to turn our problem from a regression into a classification, this would actually be something we may want to do, right? Is we want to, because generally, like if we're modeling this and we want to predict the price, this is a regression. Certainly, like predicting this price would be a regression problem because we're predicting a real number, right? A continuous number. That's a regression problem. But if we map this price into a bucket like low, medium, high, or we have these labels here, which would be 0 to 100, 101 to 200,000, 201 to 300, all these buckets. It then turns into a classification because we could try to predict those. We could try to predict this price category label, which then makes it more like a multi-class classification. Um, and that may be something we care more about is getting the range correct rather than the actual value correct, which is generally hard to do with a regression, right? We know that's historically hard to get that exact value correct, which is why we have these error functions like mean squared error, right? That just measure the distance from our prediction to the value. So there, just to say, there may be some situations where we map our target into discrete buckets like this, and a function that can help us do that is this PD cut, which can generate buckets of values for us, given different labels and given different edges which define the bucket edges for us. So if we take a look at applying that, we get these price categories here. Of course, we want to be smart with what buckets we come up with, or else everything could be thrown into one bucket, which we want to avoid. So these edges aren't very good because so many things end up in this bucket. But that's greater than 500, and uh, so that this would probably want to change this to into the thousands at least, to be more relevant price buckets. Well, hopefully that makes sense. Like that may be something we want to do, uh, if we're converting over from a regression to a classification. Okay. Now, one more thing I wanted to discuss here is dealing with, so we've talked about handling missing values, talked about transformations we can do on our data, which we'll come back to. Um, and the next thing that's worth talking about is handling outliers. And there's many different ways to identify an outlier. Um, I'll tell you probably the most common way of doing it, which is actually this, which is we covered this, back when we were talking about outliers a little bit, which is mapping all of our values to a z-score, right? So this is the standard. This is what we typically do. We typically do with the standard scalar from sklearn, right? So this is the transformation that it does to all the columns, which is take the column, subtract off its average, and divide by its standard deviation, right? That's the standard scalar, exactly what it does. Um, but the reason to do that for outlier detection is once we have converted that over to what's called the z-score, we can examine that to see many, or essentially what the absolute value of that is, and is it very large? Because what the z-score is supposed to represent, remember, is something like on the bell curve, basically how far away you are from the mean. So the mean's at the center, and we've centered everything to be assuming the mean is the center because we've subtracted it off from everything. The z-score is kind of telling us how many standard deviations are we away from the center, right? Are we one to the left? Are we one to the right? Are we multiple to the left, multiple to the right? And so if this z-score kind of tells us how far away we are from the center. So if we are several standard deviations out here, then that's more likely to be an outlier, which means we're something down here in the tail, right? Something like a point down here, it's going to be significantly far away. This is 1 sigma, 2 sigma, 3 sigma, 4. And so these are the z-scores, right? -1, -2, -3, -4. And then on the right-hand side, it'd be just the positive version of this, right? So 1, 2, 3, 4. And so the z-score can tell us how far away we are from that center. The larger the number, the more of an outlier that truly is, right? Um, And so all we have to do then is set up a threshold. Essentially, we just have to threshold this and say everything above 3.5 or everything above 4, whatever that number is, we can set up a standard threshold. And anything above that in terms of absolute value, like is it because it could be above or below. So anything that's way too far this way or way too far this way would be considered an outlier. That's a very, very common way to do it. So then that's what we would be looking for is doing a calculation like this. So we actually examined the absolute value of it. Anything above 3.5 sigmas, distance would be considered an outlier. And when we ran that, we had about 9 of those points that popped up that were pretty far away from their average in terms of the price. And that's just for the price column. Obviously, we could apply our standard scalar and apply this to all columns and see which columns have outliers. But um, then becomes the question, what do we do about the outlier? And it's the same kind of thing with null values. There's different ways to handle it. So you could drop them. That might be something we want to do. We could also cap them. So we could kind of cap them to be instead of being so significantly large, we could cap them at kind of like the 75th percentile value or some range uh, above the 75th percentile, which is what this does. So the winsorization function that we had earlier, this one will cap the values to be within like 5% above and below the 25th and 75th percentile. Um, so uh, we could run a function like that to run caps. We could also just drop these points that are considered to be significant outliers. Um, you know, we could drop those rows as well. So once we identify outliers, just a matter of how do we want to handle it? Do we want to cap it? Do we want to drop it altogether? Do we want to leave it in? That could be another option. It's just maybe we're comfortable leaving that in because it's a valuable data point. Even if it's an outlier, it's still like in the prices, it may be a reasonable data point, even if it's an outlier. It could just have a large price, but have a significant number of bedrooms, significant number of bathrooms. It's still a meaningful point for modeling. It is an outlier relative to the rest of the data. So um, it's a decision. What do we want to do with those? But it is good to try to identify them. By the way, we have another technique of finding them, which we covered in our machine learning course, which is known as the isolation forest, right? So there's a model, there's many techniques to finding it. This is a very, very basic statistical one, which is looking at the z-score. Um, an alternative is using an unsupervised model like isolation forest. Um, we saw that in our machine learning courses using the isolation forest, which can try to identify an outlier um, through a modeling technique to essentially make a bunch of splits and figure out which points are isolated, um, which would be candidates to be outliers, right? So many different ways to identify one. Um, these are just a few. Okay. Any questions on outliers? Okay. Very good. So then the last thing that's in this notebook that's worth just mentioning, we haven't dealt with this really much, but remember we had a bunch of details in here about merging and joining. And concatenation. So just to review that really quickly, because it's been a while since we've had to do that. Um, Remember, we have various ways of bringing together data frames. The most basic way of bringing together a data frame is concatenation. This is literally just adding on rows to rows or columns to columns, which is just a way of kind of adding together two data frames that when it makes sense to kind of combine their rows or combine their columns in the simplest way possible. Concatenation can do that. And so we have this function pd.concat, and you pass in a list of data frames that you want to combine, which will stack them either horizontally or vertically, um, depending on the axis parameter. Like this is an example where we just want to take this data frame. We want to take this one and this one and this one and just stack them on top of each other so we end up with one big data frame that has all of these rows. And that's a very natural thing to do because they all share the same columns. So we're just literally concatenating them together, in which case we have a list of data frames and we run pd.concat with that list. So this concat function takes in a list of data frames, and just combines them together. So you can see the result here has all of those rows stacked together. So just reminding us of that. So that's simple. What's more complex is definitely doing merging. That's way more complex, is thinking about merging data frames, which is a more traditional kind of database style join operation. So we covered this. There's many different types of those we can do, which all come down to you know, figuring out where do we have overlap in the data frames, and if we don't, which one do we use as kind of we're going to keep that no matter what, and the other one, if there's no match, we're going to have a null, where we are adding in that data. Um, so I won't go through all of that review now because it's quite a bit. Unless you guys want to review all that. But just keeping in mind that merging has different strategies, right? It has like looking for only things that have overlap, looking for things that we keep everything from the left data frame, keep everything from the right data frame, and look for overlaps. But essentially, what we're doing is combining together data frames where we want to find where they overlap, and then bringing all that data together from the two frame from the all the columns where they actually do overlap, all the entries where they do overlap. So we had different strategies there, this is all, related to kind of a database style merging. And so there may be cases where we have to do this, like if we have multiple data frames. I think we saw an example of this most recently in our modeling course where we had like a rating CSV and a user CSV, and that would be a good opportunity to kind of merge them together, or like a rating CSV we could merge together with another one that had, I think we had a data frame that had all of the um, like metadata about those movies or products. So we had like an ID, like a product ID, and then in another data frame we could merge on that key, so on the product ID, to bring all that metadata, and kind of merge it together with the product rating. So that'd be a good use case for kind of merging multiple data frames. Okay, so this is a good, if you ever need to look back on how to do that, this data wrangling notebook's a really good reference for merging data frames. So thought I would call that one out. We haven't had to do it much, but if you ever need to, this is a good reference for how to do it. pd.merge. You can also alternatively join if you are merging on the index. So in particular, you are merging, but you care more about you're actually, rather than using a particular column by default, you're using the index, which is kind of rare. You don't generally do that. You generally use a particular column, like an ID, something like that. But in case the column you want to merge on is the index, then you can use the join function, which is a particular merge that just uses the index as the reference for overlap. Any questions on merging? Hopefully that rings a bell on us going through this. And these pictures are really, really great too. to kind of orient you to what the results should look like. So I'm going over to 3.2 in the machine learning course now. So I'm swapping over from, we had just covered some wrangling, so working with some data frames. I'm now progressing into our machine learning course. Just wanted to review some basics on modeling, so it's been a while since we've done that. Um, so wanted to cover that from the perspective of regression and classification. But I'm starting here in 3.2 notebook, which is in lesson 3 in the machine learning course. Um, so I mainly wanted to talk about these two because we've been spending a lot of our time lately on uh, working with neural networks to do these kind of problems with classification and to a lesser extent regression. But of course, the data that we've been working with there in the models that we've been using there are much different. So they are obviously neural networks, and the data that we're using there are have recently been very unstructured, things like images, things like text. Um, so it's a much different problem. But if we go back to, machine learning, it gets a little bit simplified for us because the models, I think, are easier to kind of grasp and the data is way more structured. So I think for us, it was a really good progression to go from, um, learning about modeling in this more basic format and then progressing up to neural nets was a very abstract kind of idea, and a much more complex idea. Um, but it's been a while since we've gone back and covered this, so I thought I would, and go through some examples with us, particularly that I think will be useful. So remember with regression, or I should say with supervised learning, we have two kinds of problems we're mainly interested in, regression and classification. And the regression is the prediction of some type of continuous value. And the inspiration for this is kind of a picture like this, where we have a bunch of data points, and which could be uh, plotted based on their features, right? So we have like on the x-axis um, some feature, and then in the y-axis is kind of this dependent value, which is the label, so like the price, let's say, or the temperature, or whatever it is. Um, and our goal is to build this model which represents this kind of line of best fit, right? It's this line of best fit that goes through all the points that is designed to minimize this distance between the points and this line. So that's what we're trying to do with a regression is ultimately find that best fit. And this line has a formula to it, which is for linear regression, is more generally. So this is the simple version with only one feature would look like this. But we know that there's generally we're dealing with this formula for a more uh, realistic example, right? So this is that line where we have a bunch of coefficients multiplying by the feature values, and then this produces the output, which represents the target value that we're trying to predict. Um, and so our goal in building a model with regression is trying to, especially in linear regression, is trying to find these coefficients, right? And now in neural networks, this has a very big analogy to what we've been doing recently, because these coefficients are kind of like our weights, right? They're kind of like all those weights that we were learning in our neural network. It's actually a very similar analogy there. Um, I think what's better and easier to grasp about this linear regression, for example, is that these weights have a really direct interpretation because they multiply these weights or coefficients multiply directly by a feature, and there's kind of one unique weight per feature, which is you know gives us insight into what that factor means in terms of that feature, like how much weight or emphasis is on that feature versus another. Um, and so there's kind of a direct interpretation of these weights in a lot of ways that we don't necessarily get in a neural net, right? It's way more abstract. We have all these hidden layers with lots of neurons. And then we have all these complex computations like convolutions and recurrent layers and et cetera that make things way more complex than this. So, um, linear regression, I think, is much easier to grasp from a model perspective. But that's ultimately what we're trying to train our model to find are these weights in a similar fashion to our neural nets, right? So just doing the example here, we load this data from this URL. So we can even run this together. So let's run this. We import pandas and Seaborn and Matplotlib just in case we need them. Um, and we load this data set here to build a model against it. It's just a very simple data set that only has one feature essentially, which is the TV feature. And then we're trying to predict the sales quantity. So it only has those two. It only has 200 rows. Just a very basic example to build a linear regression off of. Um, so walking through that process, it's our typical process, right? We split apart the features, we split apart the target. So we have our features X, which are basically the first column, and then the target is the second column. We're using iLoc here as we talked about earlier. This is grabbing all the rows, but only the first column because this index one doesn't get included. And then this index one would be used because it's the only value there. We're not doing a slice, so this would grab the target and separate that out. And then we can do a train test split, right? So we can do a train test split, which is pretty typical to take our features and our target and go ahead and split those apart into 70% training, 30% test. Remember, this test size is configurable. We can change it anywhere from like 20 to 30 is fine. That's a pretty standard. Zero point 0.2 to zero point 0.3, anywhere in there is perfectly normal as a test set size. So that will split that apart. And then building the regression is actually really, really easy. If you guys remember, like we have our scikit-learn models, which make everything really nice and easy for us. Um, we import from the sklearn linear models module, we import the linear regression object, and we have a simple linear regression, and we just fit that with our uh, data, right? Our features and our labels. And that's a very standard interface for all these, scikit-learn models. They pretty much all use .fit and .predict, and that's actually what we see a lot with TensorFlow too, right? The .fit kicks off the training, um, and the .predict uses the network to predict. So a lot of that's pretty familiar to us from scikit-learn. One thing I should point out too is now that we've studied this a little bit more in depth with deep learning, we should appreciate this .fit, I think, a little bit more because what this is really doing underneath the hood to find those betas and really fill out that model, right? So if I scroll back up a little bit, in order to find these betas, um, we actually do a process that's entirely equivalent to what we do with neural networks, which is gradient descent. So we do an optimization process to find these betas by doing gradient descent, computing the loss, which is the mean squared error, taking the derivative of that or the gradient of that, and using that to update these weights. So all of these weights get learned, they get updated through a gradient descent process. And that's, we can train linear regression in the same way that we're doing gradient descent essentially for neural nets. It's all optimization. we're trying to find the optimal betas to minimize the mean squared error. So why not use gradient descent, right? That makes a lot of sense. And so really underneath the hood of this dot fit is this gradient descent process that is solving for that optimal least squares regression model, right? Using this data. So we can appreciate that a little bit more now that we've seen that in action with our neural nets. It's also what's helping learn the betas here for linear regression. And we can see what our coefficient is. There's only one of them, obviously, here because we only have one feature. So there's just a single beta, which is this coefficient. And so that's the weight that is on that one feature, the TV's feature, to predict the sales. And then we can plot our prediction. So we can use our model to predict on the test set, and we can plot our test set features along with our predictions, which would generate the line, and we can see kind of what that line of best fit looks like for that one feature amongst all the points. So you can see this is the line that has that minimum error or that minimum distance. And it looks like it does a pretty good job, except for, all the way out here, there seems to be some points that are kind of far away from it. Like this, these guys are kind of far away. But like here, it does a pretty good job of getting these ones right. Just a little bit worse out near the edges. Um, but that's kind of what the model looks like. So very, very simple. Obviously, there's only one feature, so it's not that interesting, uh, but that's how we can train it, right? Is um, just doing the dot fit, and then obviously we can use it using dot predict. That's a pretty standard way of using these scikit-learn models. Okay, so I just wanted to go through that. Any questions on basic linear regression now that we've stepped beyond that and looked at neural networks? Do we see, like, does the analogy I'm saying make any sense at all on this betas, like solving for these betas? Hopefully there's a connection we can draw back to that conceptually, right? Because that's what we're doing with neural networks, just on a larger scale, right? This is a much more sophisticated process with a neural net because it's not that simple of a model. This is very, very simple. It's just betas times features. With a network, we have layers of computation and activation functions, and so there's much more involved than just this simple linear function, right? So the process is more involved, but the concept is the same of gradient descent to solve for this optimization. This feels super easy after doing after doing PyTorch. Yes, it's designed to be that way. Um, it's designed to be that way. Like I think we would have I can speak to myself. I would have struggled if I would have learned neural networks first and then tried to learn machine learning second. I don't think that's a good way to do it. I think going through the machine learning first, so we build up some intuition on modeling, um, I think is the right way to go. But even recognizing that working with neural networks is much more complex. Definitely. Whether it's in PyTorch or even TensorFlow, way more complex. Definitely agree on that. Which is why not everybody studies neural nets. Remember, I've been saying that a lot of people just stop here. They learn machine learning and they kind of just use that, which for some roles and some industries is fine. That's all you need. Um, I would argue though that with all the generative AI craze, it's really helpful to know deep learning because all of those models are based on deep learning, right? Generative AI is all based on deep learning. So it's helpful to have a background in it, even though it is, yes, more difficult. And this seems a lot easier compared to that, for sure. Okay. So also, before we go on to classification, there's quite a bit of extra material in here that may be worth reviewing on your own too. Um, by the way, we've talked about overfitting and underfitting quite a bit, so hopefully we have a good intuition of that. But that's the first time we kind of discussed that here was, how do we perform against a training set versus how do we perform against a test set? And even with a regression, we can capture that in our error, and we can see that, if our error against the test set or against the training set is much different than our error against the test set, we likely have overfitting. It may be that we have underfitting if our errors are really, really high to begin with, especially against a training set that indicates that our model is likely too basic, it's underfitting, and we need to make it more complex than just linear regression. Um, so this is the first time that we really discussed that, but I think we have a good intuition of it now, is looking at that difference in errors from training to test set. And remember, if there's a significant difference training to test, that generally means overfitting. And the goal is, this is what makes machine learning so difficult, machine learning and deep learning really, is that generalization. That's our goal, is to have this model be able to operate on new data, right? So, because we want to use these models for something like a new prediction, um, and therefore we want it to generalize, but that can be very difficult to do. Is learn against a training set, but not overfit to it, right? That's definitely a challenge, and we've seen that with deep learning in particular. Big challenge. So this is the first time we saw that, but it's definitely a topic of discussion we've had throughout ever since then. Really, is overfitting and underfitting, and we know what's happening there based on the training and test sets, right? When we see that difference, we can uh, kind of understand we're overfitting. The other topics that were in this notebook, by the way, just uh, while we're on it, was, doing things beyond just regular linear regression. So that was things like polynomials. So that involves doing a transformation of the features using the pre-processing from scikit-learn, the polynomial features, which would take their original data and transform it into polynomial features up to some power. So you can specify, like, do I want to go up to quadratic or cube or fourth power or whatever, and generate all those features and then fit the model on those guys, which may be, which may be a better fit. So you get a model that's more like this because the features have been transformed in a polynomial fashion. That may be something that is a step, like if you're underfitting with a basic linear regression and you see the trend of your point, especially if you can visualize it, you see that trend, it looks kind of non-linear. Polynomial may be the way to go as kind of the next step to see if that helps, especially if you're underfitting. Is first transforming using polynomial features and then build your model to see if the polynomial fit is actually better. So that's what we talked about there. Okay. So then we built a model on the housing data. So by the way, this was the first time, I'm just scrolling down here in this notebook. This was the first time that I think we did one hot encoding, which is important for any modeling. So just we've seen this a bunch of times, is running a function like getDummies, which will take those categorical features and, transform them into one hot encoded, which is really important for doing like a regression or a classification, right? We don't want those string features to show up there. And so when we did that, we transformed the ocean proximity feature for this data to be one hot encoded, which looks kind of like this. So now it's island, near bay, near ocean, inland, less than 1 hour from the ocean. And we get, a 0 or a 1 on all these guys, which represents that feature. So pretty common transformation, and we generally have to do that, if we have categorical features in our data and we want to build a model off of it. So something we've seen before, but um, that's something we generally have to do. Okay, so that's a little bit about regression. The last thing I wanted to remind us about, especially with linear regression, are the two variations on it. Actually, three variations, which are lasso. Um, if you guys remember, this was a regularization um, variation on the loss function. So this is the mean squared error loss function, and we've seen this plenty of times. This is the loss function that we even in neural networks we would use for regression. This is that average distance, between our prediction and the label. Um, so we that's our loss function, excuse me. And what lasso does is it makes an adjustment to that, which is adding this penalty, right? So this is the standard mean squared error. This is a standard mean squared error um, loss function, and then we're just adding in this penalty. So adding in a penalty to it. This is a way to encourage, preventing overfitting, preventing from memorizing the training data by penalizing large weights. So the only way to really keep this reduced is to discourage these from being pretty large, right? And so that's what the lasso regression has the effect of, is shrinking these. That's actually what the lasso is short for, is the shrinkage operator, because it will, in order to reduce this, the only thing you can really do is encourage these to be really small, such as 0. That's one option, is to make it 0, so that it doesn't contribute any penalty, right? So these tend to be shrunk, and in fact, some of them get reduced all the way down to 0. And that was one way of doing it, to try to prevent overfitting with a linear regression. Um, so we did an example with that. It's actually pretty much the same as running the linear regression. We just swap out linear regression for lasso. So in the modeling, here was all of our prep. And this was the first time we saw standard scalar. So this is what I was talking about earlier. Rather than individually scale every feature, we use the standard scalar, which we fit and transform our features against, to do all the z-scores for every single numerical feature, which is, we see the result of that there. And then we can do the lasso model, which is from here. The only thing we need to specify is our penalty hyperparameter, like how much emphasis are we putting on the penalty. Typical value there is 1, just a standard penalty. We don't want to be too aggressive on it, because the more aggressive you are, the more underfitting you might have. Like the model might struggle to fit. Um, and vice versa. Like if you make this too low, you can still be prone to overfitting. You're not really penalizing that much the lower this is. So value of 1 is pretty typical, but for modeling, it's pretty much the same. You just fit it on the data. You can see what some of the coefficients are. Some of them are 0, right? So some of them get absolutely wiped out, and become 0, which we didn't really see in a typical linear regression. This wouldn't usually happen. But when you're penalizing those weights, particularly, um, the model will encourage some of them to be incredibly small, if not 0, um, so that they don't bring up that loss function, right? So that was one way of doing it. The other way of having the regularization is with the what's called ridge regression, which is the um, same exact setup, but with uh, the penalty is now the square of the weights rather than the single absolute value, right? So this is pretty much exactly the same. Uh, so we have our mean squared error uh, loss function plus now an alpha penalty times the sum of the squares of the betas. Um, rather than the absolute value. So it's just slightly different, but that does have an effect in the optimization of this. The absolute value versus the square is a different gradient altogether, and so it does affect the learning process. Um, and what we see with the betas there is they don't actually, because of that square, they don't all become zero like with the absolute value. So they don't tend to get shrunk down to zero. But they do um, get encouraged to be smaller in general than they would otherwise. Um, but they don't get shrunk all the way down to zero. And so what people typically do is you can try one or the other, lasso and ridge, see which one performs best. You can basically do uh, tuning there to see which one is better. You can also combine them, which is what we talked about with Elastic Net, if you remember that. This actually combines both, so you can see it basically has both penalties. So our overall loss is mean squared error. So MSE is the first part. This. It's just MSE, that's all it is. And then here is the lasso, or what's known as the L1, and then this is the ridge, which is the L2. You see both of those penalties in there. So you can kind of add those both in there, and then have some degree of influence on one or the other. Uh, and so a lot of people go that route too and try to tune how much weight do I put on the first power, how much do I put on the second power. Um, but this is called the elastic net, is kind of utilizing both. So when are these useful? Just remember, like if you're doing linear regression and just the linear regression is overfitting, this is where you'd want to use one of these three guys. You'd want to use lasso, ridge, or elastic net. If your linear regression is overfitting, right? If your linear regression is underfitting, you need to use a more complex model in general. And this may not help you just using lasso. It's designed to be in the event that you're overfitting uh, a linear regression, right? Then you'd want to use something like this. Okay. All right. So that being said, I wanted to continue the review and move on to 4.1 and talk about classification. So, this is the problem we've probably dealt with the most in terms of, predicting a discrete category. And we've been doing that a lot recently with neural nets. But this is a little bit of review on, using models that are not neural nets, in particular, something like a logistic regression, which is actually, despite the name, remember it's a little bit of a misnomer. Um, it's actually a classification model. So I just wanted to review that, and then we have a bunch of other types that are out there, which are a little bit more complex and are worth trying if you are particularly underfitting with logistic regression. Generally, the first place to start uh, in most classification is with logistic regression, just because you want to see if the simplest model can work for you. That's something to take away from all this is that, especially with neural nets in the mix, those are incredibly complex. Those are, on the spectrum, definitely on the far end of complexity. versus something like logistic regression is definitely on the other end in terms of not that much complexity. It's very simple. It's way more simplicity to it. And then in between there, we have all these models. And some of them definitely are increasing levels of complexity, which may be useful if we are underfitting as we work our way through that spectrum. Uh, but the first place to start usually is logistic regression because that is the simplest kind of model. And what we are doing with logistic regression is typically a problem like this, where we're doing just a binary classification. Of course, it can be adapted to do multi-class classification, but typically would be used for a basic binary classification. And the way the logistic regression works is it uses the sigmoid function, which is we've talked about before as a typical or one of a typical activation functions in a neural net. It's actually used here. So we process this the reason it's called regression is we process this regression of these weights times our features. So we compute that almost like a linear regression, but we pass that through this sigmoid, which we know from neural nets, sigmoids produce values between 0 and 1, right? They produce a probability. So we take this regression and we pass it through the sigmoid activation essentially um, in a logistic regression in order to produce a probability. So the logistic regression produces a value between 0 to 1. And typically we threshold that, right? To say like anything above zero point 0.5, we predict a 1, like cancer or spam or um, whatever that represents. Otherwise, if it's lower than a half, then we would predict 0 for that class, which would be like not spam, not cancer, not disease, whatever it is. Um, but here's the sigmoid, right? And so these weights, these betas get trained in much similar way to linear regression, right? They get trained and they actually use, here's a very familiar loss function, by the way. This is the cross entropy. We actually have worked with that quite a bit now with neural nets, but it actually has its origins in logistic regression as a very typical loss function for a classification, right? So this is the loss. This is exactly the binary cross entropy that we have seen before in neural nets. Exactly this, and we are trying to minimize this. We're basically trying to learn these weights that minimize this loss function, right? Through gradient descent, and we learn these weights for logistic regression that way. What's really nice about logistic regression, though, is because it's so simple of a model, and we learn these weights, again, we have direct interpretation of those weights, right? Because every weight applies to a feature. So we basically have this weight one times feature one, weight two, feature two. That's what this is the shorthand notation for that with a dot product. Weight one, x1, weight two, x2. X is just a vector with all the um, basically all the features in it, and then W is a vector with all the weights. So the dot product is really this. And so in a logistic regression, um, we have it's just like on a linear, we have a weight that's applying to every feature. So in a lot of ways, it's like our factor or our importance of what feature led to our prediction of our probability. So it's very, very interpretable. When we have a neural network doing this kind of classification, um, we don't have that interpretability, right? It's so abstract. We have so many layers. We have different even different kinds of computation in those layers, like convolutions and etc. Very complex. So, but with logistic regression, it's very, very simple. We just have this linear combination. We're passing through this logistic function, also known as a sigmoid. So hopefully that's jogging our memory a little bit on this. We had a simple example here. I'll walk us through it of building out a logistic regression for this breast cancer data set. And so this had a bunch of different features related to imaging of those um, cells, like cancerous cells. And it had a diagnosis of malignant or benign, which was like cancerous, not cancer. Um, if you guys remember, we did this example and it had a bunch of different features here. Um, and we found out that this, this feature, unnamed, this unnamed column had basically all empty, but I think we ended up just dropping that. We see the distribution of the target, so it's a little unbalanced. And by the way, we have ways to handle imbalanced data. Well, I'll review that with us too. Um, So we can't forget that. Like if we have imbalanced data, we probably should deal with that too. And this is a little bit imbalanced where um, most of it's actually malignant, meaning cancer, and less of it is benign, which is not cancerous. Um, okay. So we looked at all of our correlations, et cetera, et cetera. It's a standard thing we do. Um, and then we encoded our diagnosis to be 0 or a 1, just because right now it was a string. So we just mapped that over to a 0 or a 1 for the diagnosis. Pretty standard to do. Um, if we're modeling off of that, we did our features and our target. We did train test split. Now, this is also a great example because it shows off the pipeline capability from scikit-learn, which allows us to put in pre-processing. So, we're allowed to have different pre-processing steps that we know will get applied to our data before we build the model, which is usually the last part of the pipeline, right? So we have this logistic regression here, which is the last element of this pipeline. Right before that, we have a scalar, which signals that we want to do standard feature scaling prior to building our model. Now, we could have many different things in that pipeline, and we actually did other examples with that, where we had things like um, filling in missing values, like imputation, right? We can have an imputer in there. We can do scaling, we can do transformations. Um, all kinds of things, but this ensures that all of these steps run every single time we use this pipeline. So it's a good way to kind of package together um, preparation or transformations that we want to make sure happen every time we use this model. So uh, we have our scalar in there, and then we have our logistic regression, and we fit the pipeline, which will scale all the features and then fit the logistic regression, and then we can do predict. Now, what's great about this predict is the predict will use the pipeline. So what it will do is first scale those features and then pass them through the model, right? Same thing with on the test data as well, right? It will scale the test data then pass them through the model because that's what the pipeline does. And if you guys remember, we can also grab directly the probabilities. So that's something that's very common with these sklearn classification models is we can actually generate a probability, which is what logistic regression does by default. It generates a probability. The predict will threshold that and determine if we get a label of 0 or 1 automatically based on that probability. But if we want the raw probability, we can access it by using the predict proba function. And we can take a look at those probabilities and we can see like Obviously, this one's really low, so it got a 0. This one's pretty high, so it got a 1. Pretty high, so we got a 1. Really, really low, got a 0, etc. Take a look at our metrics. That model did pretty well. Just basically just regression. It ended up with 98% on the training set and 97% on the test set. So pretty consistent, pretty good across both of those. We can even see what some of our coefficients were. So again, these are kind of interpreted as factors of our features, right? Which features seem to have high coefficients, meaning they contributed quite a bit towards the prediction. Okay. Let me pause there. Any questions about the logistic regression and classification? Okay. So yeah, hopefully this is, a lot easier and to digest than neural networks. Sounds like it is. But just remember when you are doing any kind of machine learning, it's generally a good idea to start with logistic regression as your first model. Um, Again, multitude of reasons for that. It's very simple and easy to explain. And based on the performance of it, then you can decide what to do. If you see it um, overfitting, then it could be that you need to maybe change some of your features, use less features, maybe even consider using more data if you're overfitting logistic regression, but more likely you would be underfitting, meaning that the logistic regression is too simple of a model. We actually need to use something more complex, like a decision tree or like an SVM or a random forest or something. But at least we have that baseline, and if logistic regression performs really well, that's great. Very simple model, very easy to explain, that works out great. So it's a good starting point, and then you can kind of progress from there. Okay. I wanted to also take a moment to remind us a little bit about the metrics that we typically deal with in classification, because remember, it's no longer just evaluating mean squared error as a metric, which we do in regression, but in classification, we have these things like the confusion matrix, um, which kind of track whether or not we get things right or wrong. Um, just reminding us of that. And, if we get, remember, this is a little off in the sense that this should be false positive here, and this should be false negative here, which is essentially like, what did we predict and did we get it right? So, in this corner, we have, we predicted cancer and it actually was cancer. So that's a true positive. So we predicted 1, it actually was a 1 label. That's a true positive down in this right corner. Those are good. Predicting not cancer and it actually being not cancer is also good. That's a true negative. So these are really good. These two cases are where we want to be. We want our confusion matrix, like a perfect confusion matrix only has entries in the corners, right? On the diagonal, I should say. Um, that's a perfect confusion matrix because it means it didn't miss anything. It got both classes correct when it made the predictions. Um, Now, errors occur on the off diagonal sections, right? So errors occur when we have a false positive, meaning we predict positive and it actually was negative. So that's like a false alarm. We predicted cancer and it actually wasn't. So that's the false positives. False negatives, you could argue, are even worse. It's where we predicted everything was okay, not cancer, but it actually was. So we missed that and that's a false negative. You could argue that's actually worse than a false positive. That depends on the situation, which error is worse. But they're both errors, and so ideally we keep these to a minimum. But remember, we have different metrics to kind of track the impact of these errors, right? We have different metrics to track those, namely things like precision and recall. So remember, precision is going to be impacted by false positives. So the more false positives we have, the lower our precision, and the more false negatives we have, the lower our recall, right? So those are just different formulas that involve these various elements of the confusion matrix. So we talked a lot about that, and um, this is something that historically I think I've noticed has tripped up a lot of learners along the way. But hopefully this, makes sense to us after seeing it a few times and dealing with it from a classification perspective on the kinds of errors our models could make. Could be false positives, false negatives, and we have different metrics to kind of track that. Accuracy is just an overall accuracy type of metric that is tracking, what did we get right out of all of our predictions. So this includes true positives and true negatives. Ideally, this is 100%, but it's not always going to be that way. But ideally, this is 100% because why would it be 100%? It's because we have zero of these guys, right? Ideally, we have none of those. So this is just this divided by itself, which is 100%, right? That'd be the ideal case. Do we always have that? No, but that's the ideal case there. Um, Now, again, where we have precision and recall is measuring the impact of false positives, false negatives. So the precision penalizes false positives because the more of those we have, the larger this denominator, which drives down the precision metric, right? So perfect precision would be having none of these, right? That'd be 100% precision. Um, and so that's, an evaluation we could make. And in some cases, maybe we want precision to be really high, maybe at the sacrifice of recall. We're willing to have basically no false positives at the cost of maybe some false negatives. On the other hand, recall is a metric that penalizes the false negative. So if this is nothing, then we have a perfect recall, right? And truly the recall interpretation is like, how many positive classes are we actually predicting correctly out of all the positive classes? How many of those are we getting right? So of course the true positives are in there because we're getting those right, but the false negatives have an impact because those are ones that we are potentially missing. So if we're not missing any, that's a zero and we have perfect recall, right? And so that's what we would strive for. There's a lot of models out there that I've seen that they're like a very typical case in the industry that I've seen is you try to maximize recall because a false negative can be catastrophic. So like I'll give you examples is like in fraud. So in a lot of fraud detection, we are okay with false alarms, like false positives, like flagging a transaction as fraud may be okay because all that might do is escalate to a human in the loop to review it. That's the worst case. And so somebody's spending their time and maybe they waste their time, which isn't great, but obviously the better we are at that, the less we would have them wasting their time. Like the less false positives we have, the more precision. That's great. They're not wasting their time. But we're willing to waste our time as long as we don't miss anything, which is what we're trying to prevent with recall. So I've seen a lot of models that will kind of zero in on driving up the recall as much as possible at maybe the expense of false positives. So they're willing to accept a lower precision, but trading that off for having a higher recall because the cost of this false negative could be really catastrophic. And that's also true in a lot of healthcare applications too, like the cancer, not cancer, right? We don't want to miss anything. False positive isn't great, but you know, missing it could be obviously catastrophic. So we don't want to miss anything. So a lot of instances where recall is desired to be as high as possible and precision we're not as focused on, we're willing to let that be lower because we're willing to make more predictions as positive in order to not miss any of those positive instances, right? Just logically, if you think about that, in order to ensure that we don't miss any of these, we need to be predicting positive pretty frequently, right? To make sure we don't miss that. But the trade-off is the more we do that, the more of these guys we're going to introduce. If we're just blindly predicting positive every single time, we're going to have a lot of false alarms, right? But what it does is it limits this significantly. So these are like ultimately kind of tied to each other, right? So uh, just something to be aware of when you're building models. That's just to say, like, accuracy may not be the only thing we ever look at. We may look at precision and recall as well. And particularly for a lot of cases, recall is uh, desired to be high at the cost of precision. Okay, hopefully that makes sense. It does depend on the, industry and application, but that's kind of what I've seen is a lot of emphasis on recall at the cost of precision. Any questions there? Does that make sense to us on the trade-off there, precision recall, and why we would look at those metrics? Okay, makes sense. Okay. I know, and I know we've covered this before. It's just been a little bit of time, so figured it's worth discussing. Let me know if there's any questions about any of it, and happy to go further into those topics as we're going along and kind of reviewing here. Okay. Um, One last thing on the metrics piece of it, by the way, is I know so we have other metrics that are out there. There in particular, there's some visualizations we can do, like the rock curve. If you guys remember, this is a curve that plots the true positive rate against the false positive rate, essentially, which measures that threshold sensitivity. Like if basically how good is our model at making predictions, given that if we were to change that threshold a little bit, would that drastically affect our predictions? Like, are we tending to make a lot of predictions right on the edge of that zero point 0.5 threshold? So if we were to move that in any way, would it drastically affect our model? And what that's designed to do is kind of measure the quality of our model and being really confident and correct, right? So what we would desire is a model that's producing a very high probability when the class is actually one and a very low probability when the class is zero. And we don't want it to be like in the middle, and unsure which way it is. We'd love it to be, you know, basically 100% probability when it's right and 0% probability when it's class is zero. So the rock curve is going to visualize that to some extent, um, which is where we get examples that look kind of like this, right? So this measures that true positive rate over various thresholds, and the perfect rock curve is a basically uh, rectangle, right? It's just one that looks exactly, or a square essentially that looks like this, because that means that uh, it didn't have any, it was basically 100% right no matter what that threshold was. That's perfect. And what we're looking for too, as a related metric, is the area under the ROC curve. And so the perfect value of that is um, 1, right? 100%. Essentially, if this area is exactly 1, that means we were always right. And we had 100% accuracy essentially. So the AUC is a related metric to the ROC curve. A really bad AUC would be like 0.5. Essentially, when your ROC curve is pretty much like that, that means your model is hovering around 50% for all of its predictions. It's not very good, and so you get about half of that area. Anything like below that or right around that, it's going to be a poor model. And so you want something really close to 1 for your AUC. So that's just that metric, um, you know, for it's as an alternative examination of our accuracy.
And that brings us to the end of this generative AI literacy session. In this video, we explored how AI can help you with writing, translating, research, sentiment analysis, image generation, automation, UI design, video creation, transcription, product planning, and data analysis. We also reviewed important machine learning concepts that are useful for real projects, AI, and data science projects. The key takeaway is simple. Generative AI is powerful, but the best results comes when you know how to guide it, refine it, and validate its output. If you found this video helpful, make sure to like, share, and subscribe to Simplilearn for more videos on generative AI, data science, machine learning, and the latest tech skill. Thank you for watching. Until next time, keep learning with Simplilearn.